Halo Reach is an epic story of interstellar war and selfless heroism. The chronologically first game in the series takes place at a time in which humanity is outmatched by a hostile alliance of numerous alien species. Through a combination of tactical genius, noble sacrifices, and advanced technology, they somehow manage to stand a fighting chance. With one of the most expansive universes in modern science fiction, Halo is widely, and in my opinion rightfully, considered one of the best sci-fi action game series ever made, putting you, the player, in the power armor of a super soldier facing the wrath of the invading Covenant Empire, with little more than a handful of guns, a lot of luck, and an epic sweeping soundtrack that turn you into one of the top 2 toughest and coolest sci-fi soldiers in gaming. As with many science fiction settings though, eventually the question is often asked of whether or not the technology that we see in the game makes any sense from a real-world perspective. And if you're anything like me, this question comes up quite a lot when space travel is thrown into the mix. Together with its amazing story, this got me really interested in investigating Halo Reach, using my experience from helping build a commercial space station, as well as 3 engineering degrees, to see if the advanced technology that we see in Halo can be considered realistic. So if that sounds like an interesting question to you, go ahead and make yourself comfortable since, as you can see by the timestamp, there is quite a lot to discuss regarding the engineering and science within Halo Reach. Now before we get too deep into the review process, it is worth pointing out that Halo is an incredibly expansive science fiction series with a scale comparable to Star Trek and Star Wars. So in order for this review to actually have a manageable scope, I won't be going into the entirety of the Halo series. However, there are some important contextual elements that we should make a note of before getting started. Probably the most important of these concerns the presence of alien technology within the game, which will require a bit of backstory in order to give us a sense of context of the universe in which we find ourselves. By the mid-26th century, the Covenant Empire consisted of an alliance of multiple sentient alien species across the galaxy. This empire was founded based on the worship of an extinct ancient alien species known as the Forerunners, who were incredibly technologically advanced to the point of guiding the development of life itself within the universe. To the Forerunners, this role was known as the Mantle of Responsibility, and one day it would be passed on to another species. The Covenant believed themselves to be the inheritor of the mantle, until a Forerunner artifact was eventually decoded that indicated that the true inheritor of the Mantle of Responsibility was humanity. This revelation was kept secret by the religious leaders of the Covenant, who feared that if this information were to be made known to their empire, it would result in the loss of their power. This soon led to the Covenant declaring war on humanity, with the intent of wiping them out completely to remove any potential threats to the religious leaders' rule. Despite the advanced technology of the Covenant and their overwhelming military power, humanity would not be defeated so easily. By the mid-26th century, under the leadership of the now interplanetary United Nations, humanity had already expanded out to multiple star systems in the vicinity of Earth and possessed a heavily militarized space program that spread throughout their domain. This included the Spartan program, designed to produce elite super soldiers by means of biochemical augmentation. The Spartans would eventually prove essential to humanity's struggle against the Covenant, as more and more worlds were lost to their invasion. This eventually led the Covenant to the planet of Reach within the Epsilon Eridani system, where the events of this game take place. Now, because we find ourselves in such an advanced setting with the presence of even more advanced alien technology, we have to be rather deliberate in how we determine what can be considered realistic in this sort of setting. As in my previous reviews, we will still be allowing one miracle exception to the laws of physics to explain human technology for every 500 years into the future that we go. This is done to account for landmark advances in our understanding of physics and the universe, which don't come about very often, as well as to afford some level of imagination to what we see in the game, while mostly staying true to the underlying physics that we understand today. However, this approach becomes vastly more complicated when we introduce multiple alien species to contend with. Each of these species has their own history of technological development, and in most cases are more technologically advanced or have had more time to develop than humanity. We also have the further complication that multiple alien species in this setting have interacted with each other in order to share technology. So while it might be possible to eventually explain alien technology with enough miracle exceptions, the obfuscated and contorted timelines of this development make it very difficult to determine what could be considered realistic using the same standards we apply to humanity. As a compromise, we can consider that alien technology is beyond the scope of this review, but we can still occasionally investigate alien technology that implements current understandings of physics on the rare occasions in which we encounter them. Now, all of this is in reference to the Covenant, and does not even remotely reach the level of technological advancement of the Forerunners. While we don't see much of them in the game, their presence does become important to the story, as do some of their technological advancements that were adopted by the Covenant and eventually humanity. So whenever we do encounter Forerunner influence, rather than relying on miracle exceptions to quantify its realism, we can instead consider a concept devised by science fiction writer Arthur C. Clarke, stating that any sufficiently advanced technology is indistinguishable from magic. The Forerunners certainly fall under this category, and so in the absence of other explanation, their influence can be filed under the separate category of sufficiently advanced technology. Now, this is all a rather roundabout way of saying that we're only going to be looking at human technology in Halo, but since aliens are a big part of the setting, it is still worth having a framework with which we can address their technology when it appears. As for the realism of human technology, usually at the beginning of these reviews we'll discuss what those miracle exceptions are and how they're implemented in the story. However, this time, the miracle exceptions only come up in very particular circumstances, and so I think our discussion is better served by waiting until we encounter them in order to discuss how they work. Now, it is also important to note that due to the extensive scope of this series, I will be heavily relying on the Halo Wiki for background information and some additional details of how things work within the Halo universe. I'll mention this quite a lot in the video, but if you have a more complete knowledge of Halo than I do, I would be more than happy to read your comments, corrections, and clarifications in the comments on this video. Also to that point, to the greatest extent possible, we'll only be focusing on the events that take place in Halo Reach, and only venturing beyond that when necessary to get additional context for what we see in-game. We also won't be covering the Spartan program here, which, like many topics in Halo, is probably big enough for another video of comparable scale. We will be going into some detail, however, on some of the more advanced weaponry that we encounter in the game. Though again, this won't be an exhaustive review of the guns of Halo, since there's quite a lot there too. I feel like I should also mention that I have not personally served in the military, so for the most part I'll avoid commenting on some of the tactical military decisions that are made in the game. Lastly, while I won't be including all of the game's cutscenes, I will have to spoil most of the story in order to give this a proper review. That said, even with knowing the story, I still greatly enjoyed replaying this game for this review, and hopefully you will too. So with all that preamble out of the way, we can finally go ahead and get started with the review, beginning with the planet from which the game gets its name. Before we get into a scene-by-scene review of the game, it's worth paying some attention to the planet of Reach, which in itself is a major character within this story. And thanks to the significant amount of information available within the Halo lore, we can actually determine quite a few details about the planet and its solar system. The planet Reach is set within the real-life star system of Epsilon Eridani. This is in fact one of the closest stars to Earth that we know of today, so it makes sense that this would be an early target for colonization. We also have a fair bit of information about the composition of the real star system as well. It is in some ways similar to the Sol system we inhabit, with a few notable differences that do actually come up in the game. The most notable of these is the presence of 2 asteroid belts within the star system. This large concentration of local asteroids leads to large amounts of dust being produced within the star system, which fill the space between the asteroid belts as well. The appearance of this dust is presumed to be analogous to the zodiacal dust that we can see in our own solar system, and so it would presumably be visible from planets within Epsilon Eridani. On this note, there's only one currently known planet to be orbiting this star, named Aegir, or Epsilon Eridani b, a gas giant of approximately the same size as Jupiter. Over a decade after its initial discovery in 2000, before Halo Reach was released, there was some debate about whether or not it was actually present, but its existence was confirmed from later observations. This planet's absence from the Epsilon Eridani system in Halo Reach could at least make sense if the papers contesting the planet's existence were published before the game's release, but since that wasn't the case, it appears that the Halo universe does not include this planet for some reason, one of which could perhaps be the astrodynamics of gas giants within solar systems. Because these planets are so massive, over stellar timescales, they have a tendency to pull in smaller masses to them from within the solar system, which could make it more difficult for other smaller planets to form. A simulation of this phenomena using parameters from Epsilon Eridani found that the existence of other planets, in particular within the habitable zone of the star, would be unlikely but still possible to occur. Thus, we don't have to completely rule out the possibility that a planet like Reach could exist in this star system. As for any other planets such as Reach being discovered within Epsilon Eridani, this has proven difficult due to the star's high level of activity, making it more difficult to confirm if observations are planets or simply the star acting up. This high level of activity also results in a much more intense solar wind than is present in our solar system. The intensity of this wind, combined with a greater amount of X-ray and UV radiation than our sun, could pose challenges to the habitability of any planets that may exist within Epsilon Eridani. However, the significant solar wind and intense magnetic fields of the star, combined with the presence of exozodiacal dust within the system, could perhaps conceptually provide the necessary ingredients for the luminescent space dust clouds that we see in Halo Reach, producing an effect not dissimilar to the aurora borealis in this part of the game, in this part of the galaxy, localized entirely within this system. We could also go even one step further than this by noting that by the color of the clouds, if this glowing phenomena is produced by the same mechanisms as the aurora borealis on Earth, the green and blue colors of these clouds would suggest the presence of atomic oxygen and nitrogen, two elements of potentially great significance for the development of life within this star system. Now, unlike previous games that I've reviewed, Halo actually provides us with some additional information regarding the nature of the planet's rotation, thanks to the inclusion of the in-game compass. Combined with the timestamps and location provided at the beginning of each level, this allows us to get a precise direction of where the sun is located at any given point in time during the day. Now, by recording the location of the sun in each mission and then plotting it on a map of the planet, we can see a trend start to form. The 3rd and 8th levels take place during nighttime of the 27-hour day, so we can't use them for determining the sun's location. I wasn't able to identify an exact location for the last 2 levels in the game, so there's a bit less certainty involving these data points. The direction of the sun in level 10 also seems to have not changed significantly since level 9, but since we don't have exact locations for either of these levels, this is perhaps less of an inconsistency. We do have a bit of an outlier in the sun direction on level 5, since we are at a much higher latitude than other levels, and yet the sun is still to the northeast. By contrast, in level 2, the sun is to the south, at approximately the same latitude. Otherwise, we see the general trend that the sun on Reach rises in the east and sets in the west, as it does on Earth, indicating that the planet is rotating counterclockwise about its axis. This is most directly demonstrated by the difference in location of the sun from the 2 levels set in New Alexandria. Now, theoretically, we probably could get more accurate numbers out of this process by measuring the elevation of the sun in the levels where it's directly visible, but the data we have is mostly sufficient to suggest that the axis of rotation of the planet is tilted with respect to the stellar system's reference plane, which is the ecliptic. This axial tilt is what is responsible for seasons that we experience on Earth, indicating that if this is the case with Reach, it would also experience seasons. As a result, from the data available to us from the game, we can deduce that Reach rotates in a prograde fashion eastward, counterclockwise about a tilted axis of rotation, with the sun rising in the east and setting in the west. All this would mean that Reach would have a fairly similar day-night cycle to Earth, as well as seasons of approximately proportionate length to those on Earth. Now, the direction of the planetary rotation will also be pretty important for our engineering analysis of a system that is particularly important to the game's story. Don't worry though, we'll get to that in due time. Reach also possesses 2 prominent moons in orbit around the planet. We don't have a whole lot of information available on these moons, but we can make some inferences based on how they're presented in-game. One of the most obvious details about these moons is how large they appear when viewed from Reach. Now, in astronomy, the size of an object in the sky is referred to in terms of its angular diameter. However, this diameter is measured as an angle, with the entirety of the sky equaling 180 degrees, which is the angle from the horizon in one direction to the horizon in the opposite direction. The Earth's moon is a decent reference for this, since its angular diameter is typically about half a degree. Degrees can be further divided into arc minutes and arc seconds, which is often useful for measuring more distant astronomical objects. Now, this all leads to the rather obvious point that a larger object further away from the observer will appear smaller than it would if it were closer. But this angular diameter is the method by which this difference is measured. We did this exercise as part of my review of Infinite Warfare's presentation of Jupiter's moon Europa, since in that case we knew all the parameters of both the planet and its moon in order to calculate the approximate apparent diameter. So while we don't have a lot of information about the diameter or mass of Reach's moons, if we use the Earth's moon as a reference point, we can deduce that either Reach's moons are much larger than that of Earth, or they are orbiting much closer to the planet than Earth's moon does to Earth. This second case is perhaps more likely to be possible for the smaller of the moons to rule, which, while larger than Earth's moon in the sky, is still at a comparable order of magnitude and diameter. However, this is perhaps less likely to be the case for the larger of Reach's two moons, Sodas Zarvis. It's quite possible I'm mispronouncing that, but don't worry, it won't be the last time. The significant angular diameter of this moon, combined with the ring system around it, suggests that it is unlikely that this astronomical body is actually closer to Reach than Earth's moon is to Earth, as this would serve to destabilize the ring system around this moon, and would also significantly limit the amount of time on a cosmological scale that these two objects could be orbiting each other before they collide. This suggests it is more likely that Sodas Zarvis is in fact a dwarf planet that, together with Reach and Tirul, is orbiting the three-body system's barycenter, the mathematical combined center of mass of the combined planetary system. Now, there's also an interesting note on the Halo wiki, which indicates that Tirul was actually captured by the planetary system rather than forming as part of it. This is theorized to be the case with some of the smaller moons of outer planets, given the significant difference in mass between the two objects, and so is perhaps the likely explanation here for Tirul. This seems less likely to be possible for Sodas Zarvis, given that it is likely of a greater proportion of the total mass of Reach, which could suggest that the moon is the result of a planetary impactor during the early stages of the formation of Reach, or perhaps that the moon formed alongside of Reach in a similar orbit that eventually decayed into a co-orbit with the planet itself. Planetary evolution is a pretty big field in itself, and isn't really one of my specialties, so if you have more knowledge on this topic than I do, please feel free to correct me in the comments. Regardless of how they formed or entered into the planetary system, the tidal forces resulting from the presence of these massive moons would be much more likely to have a very significant effect on Reach, much more so than the Earth's moon with Earth. The most obvious effect of these tidal forces would be the ocean tides, which would be much more significant and perhaps on a different schedule given the multiple moons that would be pulling on the planet's oceans. With the great mass of Sodas Zarvis, these tidal forces would also perhaps produce more significant tidal heating of Reach, which is the generation of heat within a planet as a result of gravitational forces of nearby astronomical bodies. This likely wouldn't be as significant as it is in the case of Jupiter and its moons, where the difference in mass is quite substantial, and the larger of those two masses is quite massive. But over a long enough planetary timescale, this increased tidal heating may be more likely to affect planetary geology than the way the planet might otherwise evolve without that moon. Now, the Reach that we see in the game has a number of notable geological features that would probably keep an exogeologist busy for quite some time, but there are at least some interesting points we can make at a higher level regarding some of the exogeological details of Reach. It is worth pointing out that the mountains that we see in the opening cutscene to the game are shown after the Covenant attack has taken place on the planet, so it could be possible that these mountains taller than the clouds are partially the result of plasma bombardment. Also, not to get too far ahead of ourselves, but we do also see evidence of Forerunner activity on this planet, which may also have contributed to the unusual terrain that we see in-game. With that in mind though, one of the most notable features of Reach is the variety of crater lakes that we can see scattered across the planet's surface. Now, since we have a number for the diameter of Reach, we can use this to calculate an approximate diameter of the craters. If we do this with the largest crater on the planet, Big Crater Bay, we end up with a value that is comparable to the Utopia Planitia on Mars, the largest confirmed impact basin resulting from a meteor within Earth's solar system. By contrast, the Chicxulub crater on Earth, resulting from the meteor that caused the extinction of the dinosaurs and probably didn't deliver an alien artifact to Earth, is only about 200 kilometers in diameter. If this crater is in fact the result of a meteor impact, it would have been exceedingly more powerful than that of the Chicxulub crater meteor, which would no doubt have resulted in a much greater extinction event as well if life were present on Reach at the time. This, or perhaps the other large crater on the planet, could also perhaps be the site of the impactor that eventually became Sodas Zarvis. In addition to the largest craters on the planet, there are also several more of comparable size, indicating that Reach may have suffered multiple extinction-level impacts. The presence of two asteroid belts within Epsilon Eridani is most likely the reason behind the large number of craters on the planet, but this is probably all we can say conclusively due to the lack of further information available on the masses of the astronomical bodies within the stellar system. Reach also has a prominent mountain range on the Vieira territory that most of the game takes place on. It's hard to tell if there are other mountain ranges on the planet just from looking at the map, but we do see that the highland mountains within the game are quite substantial. This is at least enough to suggest the presence of plate tectonics on Reach, which would result in the formation of mountains at the interfaces between moving plates. From this, we can further infer that Reach is geologically active, thus would have a molten core, which would also produce a magnetic field around the planet as a result of the circulation of liquid metals within the planet's interior. Among other things, of course, the magnetic field serves to protect the planet from the incoming solar wind radiating away from the star which it orbits. This results in a reduced amount of radiation that reaches the planet's surface, as well as reducing the rate at which any atmosphere of the planet is stripped away by the solar wind, both of which would serve to increase the habitability of the planet. One final note about the exogeology of the planet is that Reach is said to contain significant amounts of titanium, an essential element for aerospace vehicles today, and likely also in the future. This could probably be used to infer some details about the element composition of Epsilon Eridani, but for this review I'll just leave it at that so that astrophysicists watching can take it and run with it. Now, going more deeply into the atmosphere of the planet, we do see throughout the game multiple instances of people breathing quite comfortably without the use of additional gear. This would indicate that Reach's atmosphere contains at least a significant portion of oxygen, and likely a similarly proportionate amount of nitrogen to what we would find in Earth's atmosphere. In the presence of a magnetic field, and with a similar mass to Earth, we could probably expect Reach to have minimal loss of this atmosphere to space. The planet is also shown to have a water cycle similar to that of Earth, with natural rain being present in multiple levels. All of this together would make Reach an excellent candidate for habitability. The possibility of finding life on this planet would be further improved if we were to consider the existence of Epsilon Eridani b, or Aegir, since although it is not listed as being present in the system in the Halo lore, the presence of a giant planet within a solar system serves to reduce the likelihood of a catastrophic meteor impact with the planet, which could potentially lead to an extinction event. As we just discussed though, it seems like this is very much not the case with Reach. We also don't have much information regarding the distance of Reach from its star, other than that it is the second closest to the star within the system. With Epsilon Eridani have a comparable temperature to Earth's sun, this would mean that the star's habitable zone would be comparable to that of our solar system. A challenge to this might be the greater intensity of solar wind from Epsilon Eridani than the sun, which could perhaps be counteracted to some extent if the planet were located outside of the inner asteroid belt. However, this would most likely put the planet outside of the star's habitability zone. We did afford Reach the presence of a magnetic field, so if we work backwards from the presence of life on the planet, this would then suggest that the magnetic field on Reach is much greater than that of Earth. And indeed, we do see complex life that is native to Reach, which would further indicate the presence of a complex ecological system on the planet. We also see several more familiar creatures on the planet, although it could be possible that these were brought here along with human settlers, which could potentially pose problems for the natural ecosystem on Reach by introducing additional factors into the food chain that it may not have evolved to accommodate. This at last brings us to the human presence on Reach. The game takes place 190 years after it was first settled by humanity, who have since constructed multiple metropolitan centers across the planet. The wiki cites the maximum population as over 700 million, over double the current population of the United States of America. The wiki also states that terraforming operations were undertaken on the planet to make it more conducive to human life, which could perhaps have included introduction of additional gases into the planet's atmosphere to make it more similar to that of Earth. This may not have been the best choice for the natural ecology of the planet, but as we've just discussed, it does seem that the planet was mostly habitable before the arrival of humans, suggesting that only minor terraforming may have been necessary. The establishment of titanium mining operations on the planet would have provided an excellent foundation for its place in the interplanetary economy, and together with a comfortable atmosphere and extensive amounts of available land, this paradisal environment soon led to the development of the civilized Reach that we encounter in the game. And so, with a thorough understanding of the planet we find ourselves on, we can now begin our thorough engineering analysis of the events of Halo Reach.
Contact with Visegrad Relay was lost last night. All signals flatlined at 2600 hours. I responded with trooper fire teams, which have since been declared MIA.
And now you're sending us.
The Office of Naval Intelligence believes deployment of a Spartan team is a gross misallocation of valuable resources. I disagree.
Anyone claim responsibility, sir?
Oni thinks it might be the local insurrection. 5 months ago, they pulled a similar job on Harmony. Hit a relay to take out our eyes and ears, then stole 2 freighters from dry dock. That cannot happen here. Reach is too damn important. I want that relay back online, Noble One.
Sir, consider it done.
Then I'll see you on the other side. Holland out.
And so begins our adventure on the planet Reach. As we progress through the story, I'll include major cutscenes to provide us context with what's happening, since at times this is important to understanding what we're seeing in the game. There are several UNSC military vehicles that we get to operate throughout the campaign, and for the sake of continuity of this video and the story, we can discuss the capabilities of these vehicles as we encounter them. The vehicle most prominently featured in the first level is the Falcon. This aircraft bears an obvious resemblance to the V-22 Osprey, with the addition of two thrusters mounted near the middle of the top section of the body. The Falcon is also notably a bit smaller than the V-22 Osprey, and in Halo Reach, we see it primarily being used to carry a small handful of soldiers. Unlike the V-22 Osprey, which uses the propellers as its primary method of propulsion, the Falcon uses these thrusters to provide forward force and does not fully tilt the propellers to face forward to the extent that the V-22 does. We do see some distortion and exhaust coming out of the nacelles housing the propellers, but it seems more likely that this is the outflow from the turbo machinery running the propellers more so than an actual propulsive thruster. The open cabin design of the troop transport deck is large enough to support the bulky armor of Spartans and would allow for faster deployment and evacuation of troops, although this is countered by the lack of protection from enemy fire. We do see that these seats are equipped with safety harnesses, which would serve to increase survivability in the event of a crash, and of course to prevent you from falling out of the sky.
Commander, we just lost our signal with HQ.
Backup channels.
Searching. Nada. Can't say what's jamming us.
You heard her. Dead zone confirmed. Command will not be keeping us company this trip.
I'm lonely already.
Now before we discuss what's happening with this radio dead zone, I will note that antenna physics is not one of my specialties, so feel free to correct me if I make any mistakes here. As we learn in game, there are no signals being able to be transmitted from this particular region of Reach, and apparently no signals can be received either. In radio wave-based transceiver technology, this jamming can be accomplished by increasing the amount of noise that is present in the electromagnetic spectrum on the frequencies that are used for communication. If the frequency of incoming or outgoing signals is overloaded with noise, it may be more difficult or impossible to identify any messages encoded in those radio waves. Now, depending on the infrastructure available in this part of Reach, we can suppose that this jamming technology would have to be capable of disrupting terrestrial-based communications and likely also satellite communication systems. If this rural area of Reach is already developed enough to have cell towers, or the future equivalent, or whatever network they're using, then this jamming could be accomplished with more localized approaches. However, to disrupt direct-to-satellite communications over a large area, such as we see here, would likely require a significantly powerful source of radio noise in order to jam communications from such a significant area. This then is where the Visegrad relay comes in handy. The large antenna system is capable of focusing radio waves in a very intense manner, and these more powerful radio waves could be more easily identified as a signal versus the noise in the background. Assuming the relay is still directly pointed towards a communication satellite, or is capable of tracking one, it would also be theoretically capable of focusing received signals from a communication satellite and receiving messages from it. However, due to the significant power of the jammer in use here, smaller satellite communication systems, such as those used by the Spartans, would not be capable of discerning the communication signal from the background noise. We do, however, see that local communications within the dead zone are still possible. This most likely indicates then that a different frequency is being used here than the one that is being jammed. If we assume that L-band radio waves of frequencies from 1 to 2 GHz are being used to communicate with the satellite network, and these are the frequencies that are currently being jammed, then for these short-distance communications to be functional, these short-distance communication systems would more likely be using lower frequencies. Alternatively, regardless of the frequencies used by these shorter-distance communication systems, they may be powerful enough to transmit signals over short distances that can still be distinguished from the background noise, and or have sufficient capabilities of distinguishing signals from noise in order to be able to still read the communication signals despite the increased level of noise from the jammer. Shortly after first getting boots on the ground on our way to the Visegrad relay, we encounter several rows of crops resembling some sort of cabbage. These cabbage patches are planted with a terracing arrangement on the edge of the settlement. While it is possible that there are other small gardens of these plants throughout the area, these small cabbage patches seem much more suited towards subsistence farming than commercial farming. Throughout the settlement, we also see objects resembling hay bales, which would imply the presence of large fields from which plants could be harvested, as well as animals to which the feed could be given to. The mountainous terrain we encounter in this area makes it less likely that there would be enough space for a large open field to be available for farming large quantities of plants that could be used to bale hay. There are some relatively large open spaces that we encounter throughout the level, so we can perhaps suppose that there are some places within this mountainous area in which large quantities of crops could be planted. While it is possible that the hay could be a commodity export for this region, thus acting as a source of income for the farmers, if there is land space available for growing large quantities of crops, and you're going to be operating on subsistence farming, you would have to balance the financial benefits of growing cash crops versus growing food to stay alive. This is of course disregarding the quality of the soil in the area and the climate of the area, in particular temperature and precipitation, which given this mountainous terrain is likely to be cold and damp. On that note, we could perhaps suppose that there are not many food crops that can be grown very effectively in this area, hence the fields are being reserved for cash crops like hay. This once again brings us to the question of why subsistence farming would be present on an alien planet. As we'll see throughout the game, human infrastructure on Reach is very advanced. Not only does humanity have the capacity to travel to other planets, but they also have the ability to construct massive megacities and presumably transport materials across the entire planet. While it could perhaps be possible that this particular location is difficult to access, making cargo transportation to and from the area difficult, it seems unlikely that there would be insufficient resources to provide for the settlers of Reach, especially so long after the planet was first settled. From this then we can probably infer that most likely the farmers in this region are here by choice. Perhaps city life just wasn't for them, or perhaps there are additional political or economic considerations that made a life away from the big city more appealing. And as somebody who grew up in the middle of nowhere, I can definitely get behind that. But even still, in this advanced setting, the small scale of this subsistence agriculture is still rather curious. In several places throughout the settlement, we can find containers of what appears to be a flammable substance, judging by the markings on the exterior, which are always nice to have when you have something that could explode. The fire hazard symbol appears to be derived from the Globally Harmonized System of Classification and Labeling of Chemicals, or GHS, in which the similar pictogram indicates the presence of a flammable liquid. We could easily presume that this is some sort of hydrocarbon fuel for use in internal combustion generators, to be used for generating power for the settlement, or for use in internal combustion engines for use in driving vehicles. This could include substances such as gasoline, although the safety aspect of these containers, as well as the simplicity of this review, could probably be simplified by including the gasoline text on this logo if so. Regardless, this would still serve to indicate that the use of combustion engines for providing electrical power and or transportation is still utilized at least within these remote locations on Reach. This also does not necessarily indicate that fossil fuels are being used here, as there could perhaps be other fuels that had been transported to the planet's surface from off-world, which still require this hazard label. While they may not be sufficient to hold back a speeding vehicle, it is at least nice to see that there are some fences put up along the edge of this cliff. It also appears that the balcony of the house did have a complete rail system present until it was damaged, which if you're going to have a terrace overlooking a massive cliff, you better have at least some rails there. Coming inside the cliffside house, I will freely admit that the Earth-based architects and civil engineers probably have an advantage here over me. One of the first noticeable characteristics of this and other buildings that we encounter is the circular design. There will often be either a circular central room or an open circular courtyard in which the annular rooms are opening to. If the central room is part of the interior, this could perhaps result in increased efficiency when traversing the house, but in the case of the open courtyards, you might have to travel increased distances along the outer ring of the house. I also get the sense that these circular buildings would be more difficult to construct than rectangular ones, at least when using conventional construction technology. One possible futuristic explanation for this could be that these homes and buildings are constructed with large-scale 3D printers, and these circular shapes could perhaps be more effectively printed out of concrete using a Delta-style 3D printer. This method of automating construction could also perhaps make it easier to construct these houses in this remote area or on precarious surfaces such as the mountainous terrain or cliff faces.
Ask them what they're doing here.
Hiding, sir.
As we hear in this scene with George and the farmers, at least some residents of this part of Reach speak Hungarian as their primary language. This is also reflected in a number of place names that we encounter throughout the campaign. On Earth, the Hungarian language is rather unusual in that it is part of the Uralic language family, and thus is not as similar to Indo-European languages as those languages are to each other. With this in mind, I will be doing my best to not mispronounce any Hungarian names that come up throughout the story, but it'll probably happen anyways. This also brings up a point that I forgot to mention in my video of the altars, which is that during 2025, both Hungary and Poland sent some of their first astronauts to the International Space Station. Tibor Kapu was the third ever Hungarian to fly to space, and Sławomir Uznanski-Wisniewski was the second ever Polish astronaut. Judging by their presence in the altars in Halo Reach, it seems that both countries have a long future of spaceflight ahead of them. The Spade flatbed truck is the perfect farm vehicle for off-roading through the rough terrains of Reach. Although I might ask for a few more tie-down points on the bed of the truck for securing cargo better, it seems pretty well designed as a general-purpose utility vehicle. The Halo wiki mentions that this vehicle uses a methane engine, presumably running on internal combustion as we surmised earlier. This would be a convenient choice for a hydrocarbon fuel, as methane can be produced as a result of the Sabatier reaction, along with water, with a supply of carbon dioxide and hydrogen. At one point, this process was used on the International Space Station to remove CO2 from the atmosphere and produce water for the crew. This process has also been proposed as a method of generating propellants on other planets, leading to the selection of methane as the fuel of choice for the SpaceX Starship. If the commercial truck that we see in Halo Reach runs off of a methane internal combustion engine, perhaps it's not too far off to assume that the Sabatier reaction process has been perfected at this point in time, making methane a rather plentiful fuel source and also providing an additional means of producing water for remote outposts. The destroyed bridge and paved highway that we see along the edge of the mountain represent a significant construction endeavor that would have had to take place in order for this infrastructure to be present. We do see that this road eventually leads to the Visegrad relay, and is presumably then primarily used for resupply missions to this location. Such an important transportation route probably would justify the cost and time investments to construct this precarious infrastructure. However, the details seen in some of the bridges seen throughout this rural area, such as the lane dividers, seem a little out of place. This is most likely just a game asset being reused here, but we could perhaps say that during the construction of the primary road, since the construction equipment was already on site, they decided to go ahead and construct some high-quality roads and bridges for the local populace. In addition to the internal combustion generators we saw reference to earlier, we also see quite a few wind turbines throughout this area. Most of these are Darius-style vertical axis wind turbines, which are less dependent on the direction of the wind compared to more traditional designs of horizontal axis wind turbines. The unique shape of these Darius-style VOTs utilizes an airfoil cross-section across the entire length of the wing, and as a result generates its torque from lift rather than drag, making it more efficient for power generation. We see quite a few of these VOTs spread throughout the mountainside, which seems like it would be a reasonable investment for this remote rural community, whose power needs are probably not as large as those of bigger cities, and whose remoteness might make long-distance power transmission ineffective. Being located on a mountainside could also be effective for capturing wind that flows from the top of the mountain downwards, although these winds are also likely to be affected by regional and global weather patterns, as well as the latitude at which these mountains are located. Upon arriving at the relay outpost, we see that it is quite a bit more than a simple building to operate the antenna. In fact, there's quite a lot of support and security infrastructure around the base of the relay. Now, the term relay does suggest that this facility could be used to relay communications from orbit to additional UNSC military resources in the vicinity, thus making this outpost one of strategic importance for local military operations, which could easily justify the presence of additional security measures. Additionally, if the outpost is used to relay communication networks to the vicinity of civilian infrastructure as well, this would further increase its importance as vital infrastructure for the region. The value of this station for both civilian and military applications makes it pretty understandable why the UNSC originally thought that the local insurrection had taken down the facility. Here we see a demonstration by Noble 6 on the importance of forklift certification when entering combat zones. As you can clearly see here, operating a forklift without a license can leave you exposed to enemy fire, and may also leave your vehicle vulnerable to plasma grenades. Be sure to talk to your local Space OSHA representative if you are deploying to a combat zone in which you expect to encounter alien lifeforms and may be required to drive a forklift. It seems that the UNSC have learned from the mistakes of the First Galactic Empire by having a larger security bay at the entrance to this relay outpost than that of the Imperial outposts on the forest moon of Endor. This also implies that this entrance is used for loading cargo into the rest of the facility, although the doorway opens into a seemingly standard corridor rather than the dedicated cargo storage room we find later. We can also note on the first doorway that we see in this corridor that the doors appear to have an emergency override lever that can be used to open the door in the event of a power failure. This of course is an excellent safety feature, more important on spacecraft than on the ground, but it's still valuable here on the ground in the case of fire or alien invasion. We can also note that many of the areas inside this facility seem to be rather empty, but this could easily be attributed to game optimization. We do also eventually see that there is a large dedicated storage space for cargo deliveries, as well as a dedicated loading door for presumably larger transport vehicles. There appear to be several relatively unsecured server racks that we can find throughout the initial entrance to the facility. which could perhaps be dedicated to more minor functionality of the base that would not be used for housing secure or classified information. Further inside the facility, though, we do encounter several larger server racks with what appears to be an immersion-style liquid cooling solution. The entirety of the server racks are totally immersed in these cooling ponds, from which they can be raised to allow physical access. The containment system for the liquid coolant would also serve as an additional layer of physical security for the server racks. The continuous raising and lowering of the racks during this scene probably means the system for accessing these racks is malfunctioning. Or as a possible alternative, the racks are continually being raised and lowered to prevent the cooling liquid from overheating. Although this seems like a less than optimal solution, since you could easily have a circulating flow for the coolant to allow the heat to be transported away from the cooling pond. Another thermodynamic problem with this server rack configuration is making sure that heat is effectively transported from inside the server rack to the cooling liquid outside it. If you're only cooling the outside of this enclosure, the heat built up by the components inside the server rack has to flow through those same components inside the rack before it reaches the cold exterior. What might work more effectively in this situation would be a method for the coolant liquid to flow inside the submerged rack through dedicated capillaries and passageways throughout the rest of the internal components. Since we are still in a gravity environment, this would also mean that due to buoyant forces, as the fluid within these tubes becomes heated, it will rise, thus causing a circulatory flow through these tubes without the need for an additional pump. However, in this configuration, once the server rack is raised up out of the cooling pond, the liquid that is cooling it is no longer present. Thus, it would be less effective and potentially even dangerous to run the servers at full tilt while heat is not being transferred away from the system as effectively. At this point, after resetting a tripped circuit breaker, we have approximately reached the end of the level. One final note we can make here is that what appears to be happening when Cat reactivates the relay is that the local communication system that they're using with each other is being connected directly to the dish circuits. Presumably between the communicator and the dish, there is some level of power amplification taking place, so this would seem to indicate that the majority of the facility is still operational, it's just the human interfaces that have been destroyed.
2 minutes is too long.
Which is why I'm splicing into the main overland bundle to get you a direct line to Colonel Holland. You're in my light, Commander.
And with that, we have successfully completed our mission of reactivating the relay, although the results of the mission were much more than the UNSC bargained for, which will lead us nicely into our next level.
Cigna. It's patchy, but it's there.
I'll take it.
Let's not touch anything. You wouldn't want to ground this place.
Barely getting you. What's your situation? Over?
Colonel, this is Noble One. There are no rebels. The Covenant are on Reach. Acknowledge?
Come again, Noble One? Did you say Covenant?
Affirmative. It's the Winter Contingency.
May God help us all.
The next level brings us to the Office of Naval Intelligence Facility, Sword Base.
The Office of Naval Intelligence Sword Base is presently under siege from a Corvette-class Covenant vessel. Due to the sensitive nature of this facility, use of orbital rounds has been, for the moment, prohibited. Regrettably, my efforts to obtain relevant data on enemy forces have been unsuccessful. However, current defensive forces are insufficient. ONI has requested Team Noble's direct intervention to help secure Sword Base.
All right, people. We're stuck with that ship for the time being. Let's focus on the hostile infantry. Give those troopers a hand. Cat 6, you're out here. George Emile, you're next. Get prepped.
Let's move, Lieutenant!
It would seem that the events of the previous level were the beginning of the Covenant's planet-wide attacks, as the ship flying above Sword Base is now making no effort to conceal itself. From what we see in the game, and some notes on the Halo Wiki from the artists, the exterior of Sword Base was heavily inspired by stealth aircraft designs. This similarity may actually have some practical applications though, in addition to just looking cool. The unique polygonal shape of stealth vehicles is intended to reduce their visibility on enemy detection systems. Most notably, this would involve the reduction or elimination of characteristic radar reflections that would be seen for traditional aircraft designs, making it more difficult to identify the radar reflections as originating from an aircraft. A similar concept could be the reason behind the exterior architecture of Sword Base. Since this facility is owned and operated by the Office of Naval Intelligence, it would likely be considered a high-value target for any opposing forces that might be interested in attacking Reach. The unique shape of the building then could perhaps be employed to produce an unusual radar signature, unlike those that could be detected for other buildings. However, the unusual shape of the building could perhaps appear suspicious when viewed in the visible light spectrum, such as when observed by satellite cameras or by low-flying alien spacecraft. The exterior courtyard of Sword Base appears to be intended as a staging area for preparing military vehicles for deployment and perhaps for servicing them upon return. There are various support vehicles we can see here, including forklifts, a vehicle resembling an airport baggage handler, and a fuel tanker. Exterior preparation could perhaps leave these assets exposed to enemy detection or attacks, or possibly reduce the effectiveness of the altered radar signature of the building, but as we see in game, it does allow for the use of aerial assets to be deployed in this area as well. We also see that the gate mechanisms across the base utilize a slanted gate system that would perhaps serve to preserve the altered radar signature of the overall base. The various angled surfaces across the base could also possibly serve to more easily deflect large projectiles from impacting the base, by increasing the likelihood that the incident angle of incoming projectiles would be reduced. This level is the first point in the game where we encounter fusion coils, the futuristic version of the ubiquitous explosive red barrels. Judging from its name and some notes on the wiki, these devices are intended to store high-temperature plasma, presumably for use in fusion reactors. There are a variety of engineering problems with this approach, however. For one, plasma temperatures are so extraordinarily high that there are no modern-day materials that a container could be made out of to house a fusion-capable plasma. Instead, plasma-based fusion reactors today use magnetic confinement systems to magnetically suspend a plasma within a larger heat-resistant container. Thus, if you were to employ this practice for long-term storage of plasmas, not only would you need a massive amount of power to continuously power the magnetic suspension system, but you would also have to deal with very large magnetic fields surrounding the containment system, potentially complicating logistics. It is also worth noting the massive scale of modern-day magnetic confinement fusion reactors, and if the fusion coils are operating on a similar approach, this would indicate a massive degree of miniaturization of this advanced technology. Furthermore, the longer that you store the plasma for, the more heat that will leak out of it, gradually reducing the total energy of the system and making it less feasible to perform fusion reactions. Now, since we are 500 years in the future, we could perhaps suppose that advanced material science has solved the problem of plasma confinement. This is not a very simple assumption to make, though, since temperatures of fusion-capable plasmas often reach several million Kelvin. After all, this is literally the same process that takes place in the insides of stars. So advanced material science may not be the best approach either. Now, even if by some miracle exception we were able to contain high temperature plasma within a portable barrel that really should be painted red, this would seem to be a less than optimal method for storing reactants to be used within a fusion reactor. Unless this storage is achieved with very low expenditures of energy, the energy consumption rates required to store this plasma would likely not outweigh the energy that could be extracted from it, especially, as we mentioned, if there's constantly heat leaking away from the coil. You would also need to have the ability to store the amount of energy required to contain this plasma within the plasma coil itself, making the fusion coil overall more bulky and more complex. A much more practical solution would be to simply store the gases that will be used as reactants in the fusion reaction. These would most likely be hydrogen and helium, which can be stored in gaseous form at room temperatures, or could be liquefied at cryogenic temperatures to increase the storage density, which would most likely be much greater than the maximum density of a superheated plasma. Unfortunately, for the purposes of sci-fi world building, this reduces our storage devices down to a simple gas tank, but these fuel tanks would still have the benefit to gameplay of exploding when ruptured, and either way would likely remain a massive headache for space OSHA.
Sword Control, I see a target locator. Any artillery support in the area?
Limited, but we'll prioritize whatever you need, ma'am.
The target locator device is an excellent example of space-based technology influencing ground military operations. In-game, it is operated by shining a laser at a target, which is then marked as a designated target for artillery strikes. Now, to an extent, it is implied that this weapon utilizes orbital bombardment projectiles, but this presents some additional difficulties we'll talk about towards the end of this level. What appears to be happening is that the target locator establishes a link with a dedicated satellite network, the individual satellites of which have imaging systems that can be used to image the user's location. When the target locator laser is shined at a target, the reflected light is then captured by the satellite imaging system. The laser beam is quite minimal in-game, so we can presume that the reflecting laser is in either the infrared or ultraviolet spectrum, and is much brighter in those wavelengths than the visible light laser that we see in-game. thus allowing the satellite to identify the reflections from its orbital vantage point. We also see that once the target locator has identified a target, the designator is locked on to the target even if it moves. This could mean that once the satellite has observed the painted target, it can maintain visual identification of the target even as it moves around. Once this target has been established, the satellite network can use the location reported by the target locator, in addition to the laser direction and distance, to identify coordinates of the painted target. These coordinates can then be fed to either an artillery battery or an orbital strike platform, providing them the necessary information to calibrate their weapon systems to fire at that particular location. We also see that the target locator has a limited number of uses available to it, which could perhaps be attributed to the limited amount of time that the support satellite will be overhead. Depending on the satellite's orbit, within the amount of time that could be reasonably expected for the player to fire off all the rounds of the target locator, the satellite may have orbited too far away for it to be able to view the target locator. Of course, this problem could be alleviated with additional satellites in the network, and perhaps could be implemented with even basic spy satellites that don't have the necessary dedicated communication systems. However, in addition to the simple possibility that there aren't that many satellites to choose from, since this whole operation involves lethal military force, you would definitely want to make sure all communications as part of this operation are secured, and there's no possibility for a target to be misidentified. And as a result, an argument could be made that only dedicated military satellites would be employed in this target designation process. There are two noteworthy vehicles we encounter in this level, those being the Pelican aircraft, which we will discuss shortly, and the Warthog, presumably named such for the tow hooks on its front, but otherwise there doesn't seem to be much reason for this name, or why it would be better than something like a Puma, for example. The vehicle is lightweight and lightly armored, with little capacity for troop transportation, but it is capable of supporting a mounted weapon with a 360-degree targeting sweep. In most cases, this weapon is a mounted minigun of sorts, but we do see a few other weapons employed in this purpose as well. The Warthog can also be configured for troop transport, but in its typical config, it seems best suited for scouting operations, light support roles, or rapid strike operations where firepower needs to be delivered to an area of operation very quickly. We can also note that the Warthog has pretty loose handling, presumably by design, which in addition to providing some tactical usefulness, could also possibly simplify the mechanical design by loosening requirements on the tire materials and the drive system. If a general purpose tire can be designed such that the vehicle can drive with approximately similar loose handling on the majority of surfaces that the vehicle is expected to drive on, the overall drive system would have to be capable of supporting a wide variety of drive parameters. However, if only loose handling is required, there doesn't need to be as much optimization done for improving performance on particular surfaces, although instead, the design would need to be optimized for a broad variety of conditions. Essentially, it's the question of specialization versus generalization, and it's not always easy to say which is the more practical to implement versus the more practical to design. Finally, we can mention that in this level we do encounter a Warthog with a Gauss cannon attachment, but since this technology will come up again later in a big way, we'll wait until then to discuss it.
The old Farragut station has its own comms array. That should bring us back online with command.
The Covenant have seemingly disrupted Sword Base's primary communication systems, so instead we need to reactivate the communication systems at Farragut Station. Here, the communications array seems to be the primary feature of the outpost, which is very small. These buildings appear to be constructed out of a form of cobblestone or concrete and wood. The concrete elements of this construction could presumably then still be constructed using the building 3D printers that we surmised from the first level, and the wooden components could be either added after the fact or used to rebuild damaged sections of the base. Alternatively, if the building 3D printers were not used for this particular emplacement, this circular building design could perhaps be employed to preserve similarity between facilities in the event that they were ever needed to be upgraded in the future. Inside one of the buildings, we could find 3 generators that appear to be used to provide power to the antennas. If we assume that the substance being emitted from these generators isn't smoke, it's steam, then combined with the relatively simple construction methods here, we might be tempted to suppose that this is a simple steam generator. Although this would be quite out of place in this otherwise very futuristic setting, this could maybe make sense for this rather bare bones outpost that is located near a water source. Another explanation that perhaps fits into the setting a bit more could be that this is a hydrogen-oxygen generator, more commonly referred to as a fuel cell. These systems take a fuel and oxidizer, in this case hydrogen and oxygen respectively, and extracts electrical energy from the chemical reactions between these two substances. In the case of hydrogen and oxygen, the output of this reaction is water. So if this reaction were being performed at sufficiently high temperature, the water could be vaporized, resulting in the output of steam. A final note we can make about Farragut Station is that it has only 3 small antennas that are pointing in fixed directions, limiting their versatility for emergency communications. However, assuming this facility was originally constructed for military operations, it is likely that the alignment of these antennas was selected to properly align with other military communications infrastructure. Alternatively, the messy cable management could imply that the antennas have been relocated to face other military installations, or that they have just recently been serviced, or nobody cared to do it right in the first place. The other vehicle that we're introduced to in this level is the Pelican. This is the UNSC's dedicated dropship aero spacecraft, capable of operating both within an atmosphere and in outer space. It is also seen to be capable of carrying a significant amount of mass and payloads, as we can see it delivering vehicles as well as carrying personnel. From an aerodynamic design perspective, however, the design of the Pelican could use some work. For one thing, a Pelican appears to maneuver primarily using thruster pods that are actuated on both its wings and 2 tail thruster nacelles. However, the aircraft does not have much in the way of aerodynamic control surfaces with which it could take advantage of aerodynamic effects such as generating lift, or to use as control surfaces for improved maneuverability within an atmosphere. Thus, the Pelican would be largely reliant on its thrusters in order to keep it aloft, and control would be essentially limited to thruster throttling and vectoring. This would have the benefit of allowing the same control systems to be used within atmospheric as well as space flight. However, we can also see that the thruster layout is biased towards upwards and forwards propulsive force, while downwards and backwards thrust would also be necessary to have when operating within a space environment. Of course, since the wings and aft nacelles are vectorable, this could still be resolved by simply pointing the thrusters on the wings in the correct direction, though you might have to spin them around quite a bit to get them aimed correctly. On the plus side, while we don't necessarily see whether or not the Pelican is designed to be capable of atmospheric re-entry, the mostly blunt forward end of the vehicle would at least be conducive to forming a bow shock on entry, which could help reduce aerothermodynamic heating to more manageable levels. Of course, none of this has considered the actual propulsive capabilities of the engines within the Pelican, but we'll hold off on analyzing these propulsion systems for now, since this question will come up to a much larger scale in the near future. Lastly, it is interesting to note that the Halo Pelican bears some similarities to the UD-4L Cheyenne utility dropship from the movie Aliens. Additionally, the Raven dropship from Call of Duty Infinite Warfare bears a lot of similarities to the Pelican design, and the Federal gunship and Diamondback Explorer in Elite Dangerous also bear some distant resemblance. The anti-aircraft guns mounted around Sword Base appear comparable to the GAU-8A Avenger machine guns used by the A-10 Warthog. The drum magazine and magazine feed systems also appear rather similar to this weapon. The Dutch Goalkeeper close-in weapon system also utilizes this machine gun, with a different form factor but a similar purpose to what we see in Halo. Considering the massive destructive potential of these advanced weapon systems, presumably becoming even more optimized after 5 centuries of further development, it would probably be wise to have a more complex activation process than simply hitting a panel, which has nothing to prevent somebody from accidentally bumping into it, and is exposed to the air and facing away from Sword Base, potentially leaving it vulnerable to attackers or clumsy personnel. Likewise, it also seems like a bit of an oversight that the main gate for Sword Base can be opened with a simple keypad on the exterior of the base. This keypad also only has 9 buttons instead of the standard 12 that would be with these alphanumeric keypads, eliminating the possibility to enter zeros and presumably to press an enter button, and to an extent making it easier to enter the base by reducing the maximum number of possible combinations. Now, even if the Covenant didn't have time to sit through and type every possible combination into this keypad, the fact that it is possible to activate the opening mechanism from the outside means that this is a potential weak spot in the gate's security where a hacker could input malicious code, or the electronic systems could be rewired in order to gain access to the highly classified military base. Although if you've managed to find yourself at this keypad, Oni probably already knows you're there, but it would still seem like lazy writing if you were able to enter the base by repeatedly pressing 7.
Welcome to the Office of Naval Intelligence. An ONI representative will be with you shortly.
I doubt that very much.
Upon entering the Oni facility, we encounter a lobby of sorts, presumably for base personnel to use when entering the facility. However, this area doesn't really resemble a military barracks, so this particular entrance is more likely to be used by intelligence personnel rather than soldiers coming up from the hangar. After the lobby, there is an advanced-looking security system which we must pass through to reach the rest of the facility. The system does not identify Noble 6 by name, but recognizes his rank of lieutenant. In addition to just being an immersion element, this could also perhaps be a method for preserving the anonymity of intelligence operators who work within this building. It is, though, perhaps a bit of a red flag that we're able to carry such heavy weapons throughout the security system while it cheerfully waves us on, but this could perhaps be an override of the default behavior due to the security breach. Once we reach the interior of Sword Base, however, the equipment filling the rooms that we pass through is pretty sparse, without much in the way of workstations or even computer hardware. Probably the most likely explanations for this are that either these areas are intended as atriums or access corridors to get to offices located further inside the building, or that the developers didn't want to add unnecessary bloat to the game. It is worth noting, though, that the entire facility can be accessed without the use of elevators, which is a very important feature in the event of a fire or alien invasion. We can briefly make a few observations about the rocket launcher that we get to use throughout the campaign. The two-barrel system provides the operator the ability to make a follow-up shot in case the first one misses, or isn't as effective as they were hoping. The weapon is capable of firing missiles in either free fire or as guided munitions toward a designated target. Since the lock-on system is not capable of locking onto individual enemy personnel, we could suppose that the rockets use infrared homing systems, or heat seekers, in order to guide themselves towards a designated vehicle. These systems have a lot of combat legacy and operate by identifying infrared radiation characteristic of target vehicles, such as jet engine exhaust, and adjusting control surfaces on the projectile to guide it towards the target. This approach allows the rocket to hit its mark without the operator continually guiding it towards the destination. An alternate approach using a high-power laser to act as the infrared source. Since, like many other weapons in the Halo series, the rocket launcher does not have sights, it would be much more important to ensure that augmented reality systems are carefully synced up with the rocket launcher to ensure that you're actually locking onto the correct target, especially when also considering that this lock-on functionality appears to happen automatically. We could also note that for the use of these rocket launchers by Marines, it would probably be good to implement a timed safety fuse to prevent the rockets from being detonated shortly after they leave the barrel to avoid self-damage. It may be worth incorporating a switch to disable this feature though, as this change would make it more difficult for Spartans to perform rocket jumps.
Corvette's hitting this base hard.
Where's our orbital support? Got to be 4 platforms that could take it out with a single map round.
As a closing topic for this level, we can investigate the destruction of the Covenant Corvette as it flies away for some reason. While the anti-aircraft weapon systems are back online, it didn't seem like the Covenant Corvette was at significant risk from ground-based anti-air systems, although it could be that once the UNSC had overpowered the Covenant aircraft, they were able to begin attacking the Corvette directly. Regardless, shortly after the Corvette begins its retreat, we see it pursued by 2 Longswords aerospacecraft. These vehicles appear to be acting as target designators to allow an orbital weapons platform to lock onto the Corvette and fire a hypervelocity round downwards into it. Now, orbital weapons platforms are in and of themselves a pretty advanced topic, and since I've already discussed them pretty extensively in my review of Call of Duty Ghosts, for now we'll just focus on the scene as we see it played out here. And of course, if you would like more technical details on orbital weapons platforms, or if you somehow like Call of Duty Ghosts, you can check out that video too. From the flight patterns of the Longswords, we can assume that once the 2 aircraft peel away, the target lock has been confirmed. From this point to the point of impact, approximately 4 seconds elapse. Now, if we consider the orbital parameters of Reach to be similar to those of Earth, we could use this as a basis to suppose that the orbital platforms could be located in a low-reach orbit, which could be comparable to the equivalent low-Earth orbit at an altitude of approximately 800 kilometers. There's actually a fair range of altitudes which can be considered low-Earth orbit, but this number is convenient for the sake of simplifying these calculations. In order for the orbital bombardment projectile to travel this distance in about 4 seconds, the projectile would be traveling approximately 200 kilometers per second, or roughly 12,000 kilometers per hour. This is nearly 100 times faster than the fastest muzzle velocities recorded for Project HARP, one of the largest projectile weapons ever developed, which was capable of firing projectiles into space. And while it is not stated in this specific instance, later on we learn that these orbital weapons platforms utilize magnetic accelerator cannons, which are effectively massive coil guns. These will come up again as a major plot point in a future level, so we'll talk about them in more detail there. While we would probably have to know some numbers about the capabilities of the Covenant vessel's shield systems, it's probably fair to assume that this projectile velocity is sufficient to puncture the vessel entirely. And with that, we have successfully defended Sword Base from the Covenant attack, and can move on to the next mission in our planetary defense campaign. The next level takes place several weeks after the successful defense of Sword Base. In this level, Noble 6 and June are sent behind enemy lines to recon Covenant capabilities.
Recon Team Bravo reporting in. 3 and 6 in position. Starting to get crowded up here, Cat.
Then we're closing in. Report to any Covenant structures or devices. Direct action may be necessary.
Copy that.
Now, even with 20th century technology, this is something that could typically be accomplished by means of aerial recon, although the UNSC may be wary of flying aircraft over enemy territory. But conceptually, this recon operation could also be performed by imaging from satellites.
The sector ahead is dark to electronic surveillance.
Covenant can bulk our instruments?
So it would seem. And Command wants to know what they're hiding.
In-game, it is stated that somehow the Covenant is preventing electronic surveillance of this particular area, and there are several ways that this could be accomplished. One of the more technically plausible but logistically more difficult options could be through the use of satellite dazzling. This would essentially involve firing a high-power laser beam or other light source towards a imaging satellite to overload its visual sensors. Essentially, this would be like trying to take a picture of the sun with a typical camera. There are some logistical challenges to this, however, in that the Covenant would need to be able to identify and target every UNSC satellite that is imaging this territory. Even if it were possible that they were able to identify all of these satellites, these dazzlers may not be capable of blinding all satellite imaging systems that use every possible wavelength. And for example, infrared imaging satellites may be less affected by visible light dazzlers. So while satellite disruption could perhaps be a possible explanation for what we see in game, given the next topic we're about to discuss, it seems more likely that the Covenant are employing an even more advanced solution. This level contains our first encounter with the active camouflage armor ability, which acts as a functional cloaking device for the user when activated. From the Halo wiki, we can read that the UNSC developed this technology by reverse engineering Covenant cloaking devices, and so there's not a whole lot of technical detail on the manner of operation. However, there are a couple possible ways in which this effect could be achieved. A possibly more technologically feasible approach could be what is referred to today as active camouflage, and is similar to what can be seen in some color-changing animals. This process would involve using a camera to image the area behind the object to be cloaked, and then projecting that image onto the front of the object via either a screen or some other projection method, in a manner similar to the way in which some aquatic creatures are able to copy the appearance of the seafloor. This does, however, have the significant disadvantage of only functioning from one viewing angle, though perhaps with sufficient hardware, the viewing angle which is captured and reprojected could perhaps be altered by identifying the position of a viewer and adjusting the camera system to capture the image that would be viewed by the viewer in that direction. This would still only function for one particular view angle, but could conceptually allow that angle to be changed, thus allowing the solution to be mobile. However, if we attempt to implement this solution into the Halo setting, we find that it does not fully explain the phenomena we see in-game. For one, with active camouflage being an armor ability, it is something that can be attached and detached from the Spartan armor in a very quick manner. And so presumably the Spartan armor itself is not necessarily equipped with the capability to display the captured image onto its surface. The active camo is also capable of hiding its user from multiple enemies, which would require the simultaneous projection of multiple background images. Now, there is perhaps a more advanced method by which this active camouflage effect could be achieved, although with perhaps a less easily explainable implementation. The principal idea behind this approach would be to bend light waves that are approaching an object around that object and then restore the light waves on the opposite side. Since the light is not obscured by the object and it reaches the viewer successfully, the object appears invisible. This can be done with modern-day laboratory equipment using lenses or mirrors, but it requires a pretty particular setup to actually be functional. However, since it is still the same light waves that are being received on the opposite side of the object, the cloaking effect would be much more effective than that of the active camouflage approach we just discussed. In one instance, this approach has been demonstrated with a 3D printable microwave cloaking device, although this implementation of cloaking utilizes an enclosure of the object to be cloaked, so it's less likely to be the effect we see in-game. The challenge in implementing this would be the mechanism by which the light waves are bent. There has been some work in the field of metamaterials to produce objects that will bend light around themselves, although once again the effectiveness of this approach is limited to laboratory settings and very particular conditions. If we want to go a little bit beyond currently understood physics, we could perhaps suppose that since light is a form of electromagnetic radiation, a carefully controlled electromagnetic field could be used to traverse light waves from one side of an object to another through patterns of constructive and destructive electromagnetic interference along its periphery. This would then also explain why the motion tracker is disrupted when the active camouflage is working, since the electromagnetic field interferes with the radar system that is presumably being used for the motion tracker. Disruption of the cloaking effect when firing a weapon or performing other actions could also be a result of the cloaking device needing to recalculate the user's position or orientation, and so it is unable to keep up with the faster motion. Now at this point we're starting to get into pretty advanced optical physics, which isn't really my specialty, and within the world of Halo we also have the added complication that this technology has been reverse engineered from Covenant cloaking devices. So as a compromise, I think it's fair that we categorize the active camouflage as an instance of sufficiently advanced technology, more so than requiring an additional miracle exception. But we can say that there is at least some theoretical basis for this phenomenon. As a final note in our discussion of cloaking technology, we can probably assume that this is the approach the Covenant is using to obfuscate their presence in this location. However, for any Covenant equipment that is located on the ground, which would be presumably quite a lot of it, the deflection and bending of light waves around the object would be more difficult since the other side of the object is the ground. Even so, we could suppose that this technology is being used to mask the appearance of this particular location when viewed from space. While this approach may not be sufficient to make the Covenant equipment appear completely invisible, it may at least be sufficient to disrupt the UNSC's observational capabilities in the area, which, while alerting them to the Covenant's presence, would at least restrict the amount of intelligence that they can gather, thus necessitating ground-based recon. Also on the topic of optics is the hologram armor ability that we've also first encountered in this level. While the ubiquitous holographic displays that we see throughout the game are probably easily within the realm of possibility given modern advancements in holographic technology, this armor ability has a bit more explaining to do. For one, the generated hologram does not emit light, but seems rather to reflect it at the same level of another object within the same space. More specifically, it takes on the material characteristics of the object being imitated. This is much different than simply producing an emissive hologram that emits light in a manner that appears to resemble another object, and would conceptually be much harder to accomplish using purely optical phenomena. This alone probably makes the armor ability rather unrealistic, but we are able to address another technical challenge with this armor ability, which is the motion of the hologram away from the user. Now, with a currently understood holographic projection technology, the hologram by definition must remain within line of sight of the emitters. Assuming the same is still true in this instance, if the emitters were located within the user's armor, then the hologram would disappear once the line of sight between the two is broken. However, in this case, we can probably assume that something as simple as a drone is deployed away from the user with the holographic emitter technology on board. This would explain how the hologram is able to phase through some objects but is blocked by others, as only the mass of the drone is actually capable of collision. We could even say that this is the reason the hologram can only move forward at a walking pace, since the drone is limited to this velocity. We could also expand this by saying that even if the drone were able to move faster on command, the pre-programmed animation of the user walking that is displayed by the holographic projector would not be synchronized with the speed at which the drone is moving. Now, to be fair, the Halo wiki does indicate that the hologram armor ability was also derived from Covenant technology, which again would serve to imply that this is some form of sufficiently advanced technology that is capable of bending and reflecting light to match the material properties of the object being cloned. But I think if we were already reaching for an optical explanation for the active camo, I think it's probably fair to say that the replication of the light scattering and reflection properties of the materials being duplicated is not realistic. Of course, if anybody watching has more background in optics and has a more informed take on the situation, I'd be happy to hear about it in the comments to this video. One of the buildings that we encounter during this level appears to be a grain elevator. These facilities are used to store grain by transporting it from a lower location up to the top of a silo, where it is then stored for transportation later. They are a very common sight in the Midwestern United States, and there are quite a lot of towns, if you can call them that, in North Dakota and the Red River Valley that are built around grain elevators alongside a railroad track. This allows them to act as a central location for commodities that will eventually be shipped elsewhere via the railroad. The grain elevator we see in Reach appears to have a chute that leads down to a loading area, which would presumably be occupied by a truck that backs up to the exit point of the chute. This seems like a pretty logical solution given that this area lacks the dedicated infrastructure for railroad transportation, especially given the mountainous terrain. However, the efficiency of the grain loading site could perhaps be improved by removing the concrete wall that is right next to the drop-off site to allow the truck to drive in sideways and then exit sideways as well, without needing to back into the depositing site. We can also see across the exterior of the silo several pipe systems that appear to connect to various points across the silo. These could perhaps be in place due to the tendency of grain silos to explode. If enough dust gets kicked up within the confined space within the grain silo, and there's enough oxygen present in the air, it is possible for a dust explosion to occur, which can be very dangerous depending on the amount of dust that is present. So we could perhaps suppose that these pipes are in place to provide air circulation throughout the silo, and possibly also to facilitate a filtration system to reduce the buildup of dust within the silo and reduce the likelihood of an explosion. Alternatively, these pipes could be used to deliver inert gases to the interior of the silo, which would displace the oxygen inside, removing one of the required ingredients for the explosion.
Noble 2, we're at some sort of pump station. Got eyes on civilians. I'm thinking more local militia. They've engaged hostiles.
Also in this level, we find a pump station. Now, given that the next point in this level is a hydroelectric dam, it would be fair to assume that this pump station is used for pumping water. However, this assumption kind of falls apart when we see that there is a body of water right next to the pump station. However, we could perhaps assume that this body of water is not necessarily drinkable in its natural state. To that end, these pump jacks could perhaps be used to pull water up out of the water table below ground, where the various layers of sediment have filtered out the water to the point where it could be more potable, or at least requiring less treatment. Now, this implementation would probably require an economic cost-benefit analysis to compare the benefits of a pumping station versus a desalination plant, but given the remote location we find ourselves in, this could perhaps be a logical explanation if there's not a whole lot of rainfall in the area, or if there's a lack of nearby freshwater bodies. It is, of course, still possible that this is a fossil fuel pumping plant, but we don't really have enough evidence to say whether or not that is the case. This level also features the first time we encounter the drop shield armor ability. There's not a whole lot of information on the wiki about this device, although it is indicated that this is at least in part based on Forerunner or Covenant technology, thus making it even more difficult to explain how it works. What seems most likely here is that it is based on a similar principle as the energy shielding used by Spartans, with the addition of a healing system that apparently nobody knows how it's supposed to work. At the very least, we could probably at least say that the limited duration of the bubble shield is understandable since it has to be emitted from the deployment mechanism, which is presumably quite small if it can be kept within a Spartan's armor, and thus its limited power supply will probably drain faster than the integrated power supply systems on Spartan armor.
Cat, are you seeing this? Covenant structure. Kind of a big pylon. Heavily fortified.
That's the source of our dark zone.
Okay. Consider it gone.
Negative. Stick a remote dead charge on it. Command is planning something big. They say that pylon died at dawn.
The last location we encounter in this level is a hydroelectric power plant. On our way here, one of the local militia members states that a local riverbed was diverted in order to provide power for this hydroelectric plant.
Where does this riverbed lead?
Straight to the hydro plant. We dammed this river up 45 years ago. Plant powers every settlement in the territory. Shame if it all gets wasted.
Now, this might naturally raise the question of why a hydroelectric power system might be necessary in a universe where fusion power is readily available. And even in addition to fusion, there could perhaps be more effective power generation methods that could be employed here. Perhaps one of the simplest explanations to this could be simply for economic reasons, since a fusion generator is probably going to be much more expensive to implement and operate than a hydroelectric plant, and these increased expenses may not be well supported by the local economy. We could also say that logistically, a more remote area might make regular delivery of fusion fuel more difficult, and thus more expensive. A hydroelectric plant might win on both of these fronts by having the ability to continuously generate power without additional input of resources, and would require limited logistical support as parts wear out, which could possibly even be manufactured in the area, reducing the amount of deliveries required to this remote location. We could also perhaps make a more theoretical argument for the use of anything other than fusion by supposing that the area's energy needs are too low to necessitate a fusion power source, and the output of this advanced power generation technology could perhaps literally go to waste as heat, which could potentially have detrimental impacts to the local climate and environment, but we probably don't have enough information to analyze that conclusively. Also, within the power plant, we see this rather strange assortment of pipes, which seem like a rather inefficiently constructed manifold for diverting flow away from a master source or merging multiple inlet flows together. This seems like a rather inefficient way to either combine or separate flows, since if the flows are being combined here, the inlet pipes have a 90-degree bend immediately before the injection, and all of the injections happen within the same volume, producing a significant amount of turbulence. although this could perhaps be beneficial if part of the function of the system is for heat exchanging. Similarly, if this manifold is intended to be splitting the flow up into multiple pathways, then you're going to have pretty significant losses due to two 90-degree turns and a less than optimal outlet from the central flow. And I really hope the central pipe is not flowing upwards while the outer pipes are flowing downwards, since this would be very inefficient. Finally, after making our way through the hydroelectric power plant and past the Covenant pylon of dubious function, we're able to conclude the level by getting inside the Dark Zone proper and getting eyes on the Covenant's plan for the next stages of their invasion.
Jackpot. Transmitting visual. You've seen this, Cat?
Confirmed. Receiving Nova 3 and Nova 6 live visual of a Covenant strike force.
It's no strike force, it's an invading army. If we're gonna smother this thing, we need to go in hard and fast.
Agreed. All recon teams disengage and fall back. Sun will be up in a few hours, and it's going to be a very busy day.
It appears that Noble Team's discovery last night was not an anomaly. Large Covenant deployments have occurred undetected, and we are now under attack across the Vieri territory, including orbital defenses. As per the winter contingency, we are countering on every front. Noble's reconnaissance has also identified sophisticated Covenant army hiding canopies, and has pinpointed what's believed to be a landing zone for additional Covenant forces, the origin of which is yet to be determined.
And so begins the UNSC's strike back against the invading Covenant forces. This will be a fairly short level since most of the technology we encounter here will be from the Covenant, but there's still some interesting things we can talk about.
That landing zone has been tagged by UNSC Command as a priority 1 target.
Dead charge link is loud and clear. Copy that. Requiring signal lock on the pylon. Detonating in 3, 2... Incoming! I got hold on to something.
The 40mm grenade launcher that we get to use throughout the campaign has a secondary fire ability that allows the grenade to detonate and generate an electromagnetic pulse. If a vehicle is caught within this EMP blast, it will be temporarily disabled and its shields will be deactivated. What we are seeing during the explosion of the fired grenades is most likely the effects of an explosively pumped flux compression generator. This is a method for generating electromagnetic pulses by using explosives to rapidly compress the size of a magnetic field running through a conducting ring, resulting in a sudden increase in magnetic field intensity due to induced currents in the conductor. This has the benefit of still utilizing an explosive as part of the mix, so the grenade could still be functional without the addition of the electromagnetic pulse generation, by simply not discharging the capacitors into the loop by means of a remote-controlled switch. In order for these grenades to be able to produce a significant electromagnetic pulse, you would need to have pretty significant capacitor banks within them. Since it's not enough to just simply transmit a lot of energy through the electrical circuit, you have to do it very quickly. The overall design of the grenade would be such that the explosion would still be detonating in any case, and so presumably the grenades would still deal the same amount of damage regardless of whether or not the EMP is discharged. Although for some reason I always thought that the alt fire mode did less damage in game, but I don't think I have enough information to say that conclusively at this point. Since the nature of shields is largely conjectural, we can probably say that if they are electromagnetic based, it is at least somewhat sensible for a strong enough electromagnetic pulse to disrupt them. When it comes to vehicles, however, we do have a bit more real-world information to go off of. The primary concern with electromagnetic pulses and electrical equipment is that the introduction of a strong magnetic field may induce currents within electrical circuits that are caught within the blast radius. This sudden increase in current could potentially damage sensitive electronic components such as semiconductors and transistors, or potentially overload electrical power systems, and perhaps could even cause overheating if the induced current was great enough. And of course, electromagnetic communication systems could be disrupted by the noise generated by the pulse, and could perhaps even be more susceptible since the antennas could serve as receivers for the electromagnetic waves. But of course, the degree of damage done by the EMP depends on its intensity, and since electromagnetic waves follow an inverse square law, the intensity of the induced magnetic field would drop off pretty significantly as you get further away. This would explain why the grenade launcher is only effective with a approximately similar blast radius even when the alt fire is triggered. So the amount of damage done to electrical equipment within vehicles that are impacted by the EMP would depend both on proximity to the explosion source as well as the degree of EMP hardening that the electronics have received, which can be done by enclosure in a metallic surface, essentially acting as a Faraday cage, or having systems in place to dissipate or redirect, or at the very least block, excessive currents that are induced in the circuitry. And overall then, it's hard to say conclusively how seriously the grenade launcher's EMP effect would affect various vehicles. This level introduces us to the Rocket Warthog, featuring a 6-round burst multi-launch rocket system mounted on the same swivel turret we saw for the chain gun. Similar to the Revenant's MLRBs in Doom, this rocket launcher system appears to be lacking any sort of reloading mechanism, but we can presume this is just for gameplay purposes. A more pressing design challenge, though, could perhaps be the inability to cancel a firing salvo, which combined with the ability to freely rotate and point the rocket launcher in just about any direction, leads to the potential for self-damage. And something as simple as requiring the operator to continue holding down the trigger to continue firing might be an effective design modification to reduce this possibility.
6. AA gun should be in visual range.
2 Lima 4 to Noble 1. Those guns are pounding us with high-velocity plasma shells.
Now, I know I said we weren't going to look too closely at Covenant technology, but there is still a glaring design flaw in the design of these anti-air turrets, wherein the central fusion reactor is relatively unprotected, save for a single energy shield, allowing it to be easily overloaded, resulting in the destruction of the entire AA gun. Seems like a bit of an oversight, but perhaps the Covenant was just simply overconfident in this regard.
Control 2 Lima 4, permission to commence bombing run. Heading 224.6, over.
Also around this point we get our first look at the UNSC frigates that are flying in for support. Now we're going to hold off on discussing these for just a few more minutes while we get to the end of this level. But don't worry, there is plenty to discuss here.
Noble 6, there's a mining facility near your location. Covenant are using it as a command outpost. Troopers on site have already engaged.
While it is not specifically stated anywhere in game, the presence of a titanium mine in one of the multiplayer maps for Halo Reach suggests that this facility may be implemented for a similar purpose. However, it is interesting to note that there does not seem to be any designated mine entrance that we can see inside this facility, nor is the layout of the building really conducive to access to any sort of mine that could be located either underground or within the cliff face. What is perhaps more likely is that this facility is a refinement plant for extracting valuable resources from the material dug out from the mine itself. As we arrive at the mine, we can see a pipeline leading down and away from the facility, which could perhaps be used to pump suspended sediment up to the facility for further processing. This theory is also somewhat more supported by the greater presence of piping infrastructure than mining equipment. Within the mining facility, we also can find several containers marked with the appropriate flammable liquid warning label, as well as a label indicating that the contents should not be ignited. They're also painted red, which is essential for gameplay purposes. The container appears to have an outlet port on the lower side of one of the ends of the cylinder, which would make sense if you were going to be pouring liquid out of it, as well as what we can presume to be a fill port at the top of the tank, accessible via handrails that are mounted to the tank itself, which is probably not the best idea considering that if one were to slip and fall off of this, they could potentially damage one of these handrails, which are presumably welded onto the tank, and damage to these handrails could potentially lead to increased stresses within the tank itself. To that end, it would probably be better to have another way to access the top of the tank, such as a dedicated platform with a separate structural system, and also it would probably be good to have some more enclosures around these tanks if they're going to be kept out in the open. To conclude our Space OSHA inspection of this mining facility, we can briefly note that there are some safety labels present throughout the facility walls, but given the nature of this facility, this seems unlikely to fully communicate all of the possible hazards that workers might experience. One particularly egregious example of insufficient signage would be this NFPA 704 fire diamond, which indicates the presence of a highly hazardous compound, with 4 being the greatest hazard level on the health, fire, and reactivity hazard scales, but absolutely no indication what this symbol is actually referring to in this area, unless this is perhaps supposed to refer to the material that the walls are made of, which would be a massive demerit to their Space OSHA certification.
Update 6. Scans show another Covenant AA gun ahead of your location. I want you to neutralize that gun by any means necessary.
After destroying a secondary Covenant AA gun and proceeding through the obligatory turret sequence, we finally approach the first Covenant Spire.
There's the spire. Solid copy. Dot.
Latest intel suggests these spires may be projecting electromagnetic cloaking shields.
Find you one, pilot. Gotta know what's in there.
Affirmative, sir. Here we go.
Unfortunately for our ride though, the Spire's shielding system produces an electromagnetic pulse effect within our own vehicle as we pass through it, acting as another layer of security for the area inside. As a quick side note, we are first introduced to the jetpack armor ability here, but we'll discuss this later on in the campaign when it becomes more relevant. In addition to the shielding system, it is also stated that the Spires are responsible for the electromagnetic cloaking system that we investigated in the previous level. At the very least, this is probably applicable to the areas in the vicinity of the Spire, but it is sort of implied that the Spire's cloaking capabilities go beyond this.
Noble 5 only believes those spires to be teleportation terminals.
Teleporters? Linked to what?
Furthermore, the Spire is also utilizing a form of teleportation technology, which we have not seen at all throughout the game just yet, but on the bright side, the technology used for this teleportation system is at the very least something that we will address in the next level. As a bit of foreshadowing, it will probably require a miracle exception to explain. And so, with the Spire's shields deactivated, it is now vulnerable to attack from the UNSC Grafton, one of the frigate spacecraft that we saw earlier in the level. This attack is performed with the vessel's magnetic accelerator cannon, which once again we're going to hold off on discussing in great detail till later. For now, we at least get a chance to see the intense destructive capabilities of this weapon.
Control, this is Noble 1. Spire 1 is green and you're free to engage. Have a nice day.
Copy that, Noble 1. Be advised, all ground units. Frigate 318 Heavy is inbound, and MAC rounds have been authorized.
MAC rounds? In atmosphere?
One way to get their attention. Hang on to your teeth, people.
To some extent, in a manner similar to the A-10 Warthog, the UNSC frigates are built around these MAC cannons as their primary weapon. To some extent, this would explain why some of the UNSC ships resemble futuristic rifles in their overall design. According to the Halo Wiki, the Grafton is a Paris-class heavy frigate, the length of 535 meters and a mass of 1.3 million tons. This length is approximately 4 times the height of the fully stacked SpaceX Block 3 Starship. Or if you're not as into space as I am and you're somehow still watching this video, this is also comparable in size to Liberty Island in New York. Now, the insane mass of this spacecraft is on the order of 1,000 times heavier than the largest rockets that have ever lifted off from Earth. Additionally, as of time of recording, all rockets that have ever been to space have consisted of at least 2 stages, usually only the uppermost stage making it to orbit, with the rest either being discarded in most cases, or re-landed back on Earth for reuse later. This is done to reduce the total mass that must be lifted to orbit, since every kilogram is precious and expensive when it comes to rocket launch calculations. As such, oftentimes, rockets are characterized by the amount of mass that they can successfully reach orbit with, often referred to as their payload capacity or payload mass. Since greater thrust is required to enter higher orbits, rocket payload capacities decrease as orbit height increases. And most rockets are categorized by their capability to place objects into low Earth orbit. Now, some of the heaviest objects ever delivered to space are approximately on the order of 100 tons. These include the Skylab space station and the American and Soviet space shuttles. In comparison to these massive spacecraft, the UNSC frigates are approximately 10,000 times this mass. And so we would be hard-pressed to explain with our current understanding of propulsion technologies how these massive vessels would be capable of not only launching into space, but also flying through an atmosphere and seemingly hovering in place. This mass is in fact about an order of magnitude less than the assumed mass of asteroid Apophis, which caused some unnecessary panic in the early 2000s when it had a small chance of impacting Earth. Despite advancements in propulsion systems, such as fusion engines, it is here that we are effectively forced to implement our miracle exception of gravity control. While artificial gravity is a lot more commonly seen in science fiction, anti-gravity is perhaps less commonly depicted, but also possibly equally as valuable. The UNSC frigates are an excellent example of this, since if we're able to lift enormous masses into orbit and beyond, this capability would greatly reduce the difficulty with accessing space. In addition to reducing the overall launch costs for payload mass, this would also allow even more massive objects to be launched into space, which would greatly expand the possibilities for spacecraft design, as well as interplanetary settlement. So we can probably say that the UNSC frigates we see operating within atmosphere are probably utilizing some form of anti-gravity technology to reduce their effective mass to the level where their maneuvering thrusters are capable of keeping them aloft. This anti-gravity system would presumably also be implemented during the launch sequence of the spacecraft in order to reach orbit. Now, to that point, anti-gravity technology has potentially even more interesting applications once you do reach space, but we'll hold off on that until the next level, which is a perfect opportunity to explore this phenomena further. For now, though, we can conclude this level after finding out where the teleportation spires were linked to, and presumably what their cloaking fields were helping to hide, along with pretty conclusive evidence that we will be requiring a miracle exception to explain the presence of these massive spacecraft.
No, somebody tell me this ain't happening.
UNSC frigate Grafton, do you copy?
Grafton is dust. We need to get out of here now.
With an enormous Covenant supercarrier overhead, this next level has the UNSC taking the fight to space. Being a space station engineer, this is going to be one of my favorite levels in the game for reasons you'll see shortly. Also, since there's so much to talk about in this level, we will be using some of the multiplayer maps to provide us with more context to what we see in game. The level opens with Noble Team approaching a previously secret UNSC launch facility. Like many modern-day launch facilities, this one is located near a large body of water, serving to potentially reduce the damage to nearby infrastructure in the event of a failed launch. From the wiki's map of Reach, we can see that Farkas Lake, where this launch facility is located, while sizable, would not provide as much benefit in this regard as launching near an ocean. This also introduces the question of which direction that the spacecraft will be launching in. On Earth, since the planet rotates eastward, it's more effective to launch rockets towards the east direction in order to get a boost from the rotation of the planet to make it easier to get them into orbit. So if you wanted to take advantage of the large body of water next to the Farkas Lake launch facility, you would want to be launching rockets toward the west. But this would probably not make astrodynamic sense unless Reach were rotating towards the west. However, this is the opposite of what we determined from our earlier analysis of planetary rotation, wherein we identified that Reach has the same rotational direction as Earth, so you would still want to launch eastward from Reach. This boost from planetary rotation is also most effective towards the equator of the planet, since there the rotational speed at the surface of the planet is the greatest. And again, from the map we can see that Farkas Lake is pretty far away from the equator of Reach. It's not necessarily impossible to launch against the planetary rotation, but it would increase the thrust required to reach orbital velocity. As we approach and enter the launch facility from the ground, we see that it is quite heavily defended and laid out in the style of a military installation. This is definitely sensible for a UNSC facility housing advanced aerospacecraft with advanced weapons technology. However, it is interesting to consider that it is probably likely that this facility is not highly guarded simply because it offers access to space, since at this point in the future we can probably say that access to space is relatively commonplace on Reach, or at the very least doesn't require as much extensive infrastructure as we have today. Upon reaching the control room, we get a glimpse of the star of the show for this level, the Sabre aerospacecraft, all ready to go sitting on the launch pad.
George, 6, get to the Sabre before the Covenant wreck it.
What about you and Kat?
June's on his way with a Falcon. We'll exfil after you launch. Move.
You heard it, 6. Let's go.
Before we actually go on our flight to space though, it's worth taking a bit of time to make some observations from the ground. And to make this easier, we can explore the multiplayer map set in this location, Countdown. The first point we can make about the launch facility from the multiplayer map is that it is rather easy to access the blast area right below the rocket before it launches. There are a number of obvious safety issues with this floor plan, such as the flaming hot exhaust that will be fired out the back of the rocket upon launch, but perhaps less obvious is the apparent lack of a water deluge system below the rocket. This will also be seen during the launch sequence, which we will get to shortly, where we do get to see that there's no water-based sound suppression system activated. Perhaps the best way I can explain the dangers of the sound of a rocket launch is with a personal story from when we visited Kennedy Space Center when I was a kid. We were viewing the launch pad from an observation tower, perhaps a few hundred yards away, and my dad asked if it was possible to watch a rocket launch from that site. The tour guide's response was, and I quote, "What, you want to die?" He then proceeded to explain that this was not a good idea because at that distance, the sound generated from the rocket launch would be capable of stopping your heart. Now, for a more objective explanation of this phenomena, essentially, since the rocket is exhausting gases at supersonic speeds, it will create shockwaves with enough intensity to cause damage to your internal organs. In addition to ensuring that everyone is a sufficiently far distance away from the rocket before it launches, launch pads will also use water-based sound suppression systems that pour large quantities of water out beneath the rocket as it launches. This massive quantity of water absorbs the shockwaves from the rocket, reducing the intensity of the sound to the vicinity. The resulting sound is still extremely loud, but is at least less lethal than it would be without protection. Now, at the Sabre launch facility, not only do we not have this sound suppression system, but the launch site is also in a more enclosed area, presumably with personnel working inside it during the rocket launch. Now, while I will say that acoustic engineering is not one of my specialties, I think it's still fair to say that this is probably a bad idea. Even if there were a sound suppression system in this area, you probably would still not want to have personnel working within the facility the rocket is launching from, both from a sound perspective as well as for safety purposes. While we are on the launch pad, we can also see that there does not appear to be any obvious direction to which the rocket exhaust will be redirected. Typically, modern launch pads will use flame diverters to guide the rocket exhaust in a particular direction to avoid damage to infrastructure and also help with the sound issues we just discussed. Aside from an air vent, which appears to be used to deliver air to this area rather than extract it from the area, and the rather simple doors opening up to the launch pad, there doesn't appear to be any obvious flame diverter present in this area. However, it does appear that there are two different sections of the floor of the launch pad, one which is in a material that is presumably a thermal protection system, and another which we could perhaps assume is a large trapdoor of sorts, which would open up during the launch to allow the flames to be diverted downwards. As we'll see during the launch sequence, the exhaust appears to exit the facility at a location lower than the launch pad, so if this half of the launch pad floor can open up to allow the rocket exhaust to be diverted downwards, this would at least provide a better solution than allowing the rocket exhaust to completely flood this area of the launch pad. Further inside the facility, we can see what appear to be storage tanks for rocket propellants, protected by a no doubt indestructible chain link fence. If we are correct in our assumption that these containers house highly volatile rocket propellants, it would probably be better to have them located outside the facility and probably some distance away from personnel. Now, if we are assuming that we're working off of a bipropellant system, then the oxidizer propellant is probably less of a concern since it won't be able to ignite without a fuel present. However, the fuel propellant is probably more of a concern since it will most likely still be able to combust with the oxygen in the air. Thus, if there's even a small leak of the propellant within the facility, and even a small random spark occurs, much less an impact from a stray plasma bolt or bullet, the fuel propellant could go up very quickly and probably take a lot of the facility with it. A final note we can make about the launch facility is the access staircase leading to the Sabre. While it does have handrails on it, they're pretty low even for a non-Spartan, but I guess it's the thought that counts in Space OSHA inspections. But perhaps more of a concern is the actual accessibility of the Sabre cockpit from this access platform. From what we see in game, both operators of the spacecraft have to climb aboard without any obvious handholds on the exterior of the aerospacecraft. While this is a less than optimal entry method, it is possible that the full accessibility equipment required to enter the spacecraft is not present here due to the urgency of the launch. This also further implies that this launch operation is a very well understood process by this point, which could perhaps allow some preparatory steps to be skipped or shortened in duration. For instance, the aerospacecraft's propellant tanks are presumably already been filled before the Spartans arrive, and there are no pre-flight checks or tests run on the vehicle before launch. Though again, it is perhaps possible that these tests and checks were performed before a Noble team reached the rocket. I'd also like to point out as part of our Space OSHA inspection that neither of the pilots of the Sabre are using seatbelts. So, since the pre-flight checks are presumably already done, all we need to do is climb into the Sabre and wait for the rocket to lift off.
Struts disengaged. Commencing launch in T-minus 5, 4, 3, 2.
First stage engine burn nominal. Stage separation in 3, 2, 1. Stage separation.
Before getting into the characteristics of the Saber itself, we can start by investigating how it reaches orbit with its multi-stage engine configuration. There are 8 expendable components to this launch system that are attached to the Saber, which are discarded once it reaches orbit. There are 4 smaller objects that are nearly identical, which we can presume to be solid rocket boosters. Although interestingly, we don't actually see any exhaust coming out of these objects as the rocket takes off. The larger of the 2 orange components mounted on the underside of the vehicle contains a large thruster and presumably also at least 1 propellant storage tank. So perhaps an alternate explanation could be that these are additional propellant tanks. The orange component mounted on the dorsal side of the vehicle does not emit exhaust during launch, and so presumably its primary function would be to carry propellant. However, this launch stack component has what appears to be a vent system on its aft, despite appearing to not exhaust any propellant during launch. During stage separation, we can see what appear to be 2 inlet air scoops on the forward end of this orange component. This could imply that this device is intended to be used as an air-breathing propulsion unit used to augment thrust from the rocket propulsion systems during ascent. At the speeds encountered by a rocket propulsion system, this could potentially allow for operation of an air-breathing system such as a scramjet or scramjet, which require high air speeds in order to function. Thus, the system wouldn't be capable of providing thrust until the rockets get the whole launch stack up to speed. Then, upon reaching sufficient velocity for hypersonic inlet flow, this air-breathing system can provide additional thrust until we reach the edge of the atmosphere. In this case, it would probably make sense to jettison this part of the launch stack earlier than the rest, assuming that you run out of air before you run out of rocket propellant. In addition to the underside orange detachable thruster, there are 2 thrusters that are mounted directly aft of the Saber's primary engines. Since these additional thrusters block those of the Saber, they would prevent the Saber's own engines from assisting with the launch sequence. These aft engines are jettisoned from the spacecraft though, allowing the inbuilt thrusters to fully operate once the Saber reaches orbit. Now, due to the similar layout of the thrusters on the launch stack and the similar colors of the orange tanks, as well as the year in which Halo Reach was released, it's probably intended for this launch stack up to resemble that of the Space Shuttle. If we take that as the design inspiration for this vehicle, we can then suppose that at least one of these orange vessels are used to provide propellant to these additional engines. And if this is the case, we could suppose that the propellant used during the launch sequence are not the same as the one used on board the Saber, since if they were the same, the tanks could provide that propellant directly into the Saber's own propellant distribution system, which would then route that propellant to its own engines instead of having to have additional ones strapped on to block the Saber's onboard engines. Now, the mention of propellant brings up some additional questions of the rocket science being employed here. The Halo Wiki gives the mass of the Saber as approximately 58 tons. This is significantly more massive than current human spaceflight vehicles, and is approximately on par with the Soviet space shuttle Buran. It is also comparable to the combined Apollo Command Service Module and lunar lander that flew to the moon. In all of these cases, the mass of the launch equipment that is needed to get these vehicles into space is much larger than the strap-on boosters that we see in-game. If we assume that the 4 smaller stages that are jettisoned upon reaching orbit are in fact propellant tanks, then the Saber launch system also has the notable downside of not utilizing solid rocket boosters for added thrust. Since the propellant tanks for the liquid propellant engines are much smaller than these modern implementations, these propellants would need to have a greater specific impulse than modern propellants. This essentially refers to the amount of thrust that can be attained by burning a specific amount of propellant. For example, how long can 1 kilogram of propellant provide 1 kilogram of thrust? Well, to some extent, this is affected by the design of the rocket engine itself. Specific impulse is also highly dependent on the propellants that are being used. Currently, the highest specific impulse for chemical rockets is with mixing hydrogen and oxygen propellants. It is also worth noting that a high specific impulse does not necessarily translate into high thrust, which can especially be seen in the case of electric propulsion systems, which is also why lower specific impulse but higher thrust systems, such as solid rocket boosters, are used in some launch vehicles. With all that in mind, for the Saber launch vehicle to perform as we see it in-game, at minimum this would most likely require a propellant combination with a greater specific impulse than hydrogen and oxygen. Chemically, this is not necessarily impossible, as in one experimental case, a tripropellant mixture of lithium, hydrogen, and fluoride was able to produce a higher specific impulse, with the downside of producing the extremely acidic hydrogen fluoride as a reaction product. However, we have also afforded the Saber the benefit of an air-breathing engine to add on to the rocket propulsion. This is potentially a big deal, since the Aero spacecraft doesn't have to carry all of its propellant on the way up, as long as there's air present for it to breathe, and so its total mass can be reduced. However, depending on the fuel used for mixing with the air, it is still probably unlikely that this propulsion system would outpace the performance of a solid rocket booster. Finally, it is also perhaps worth noting an experimental propulsion system that was in development during the same time as Halo Reach, which is also called Saber, the synergetic air-breathing rocket engine. This system would utilize a combination of air-breathing and rocket engines, which would switch between the two depending on its velocity. This system was being developed as a potential single-stage-to-orbit spacecraft propulsion system, but unfortunately, before they could test it, the company went bankrupt in 2024. If a propulsion system such as this were ever to be actually developed, perhaps with a few centuries worth of refinement, this could perhaps allow for more effective small launch vehicles such as we see in-game. As a final note on our launch system, while we have afforded ourselves the miracle exception of gravitational control and anti-gravity, it is indicated that this technology comes with significant power consumption requirements, presumably making it less feasible to implement on such a small aerospacecraft. Besides, it kind of makes the rocket science a bit more boring when you just say that you have this advanced technology that makes your ship as light as a feather. Now that we've reached space, we can shift our focus to the design and operation of the Saber itself.
Noble 6, these Sabers have been customized for orbital defense. You may need to get reacquainted. Rendezvous at Anchor 9 with Frigate Savannah and the other Sabers as soon as you're ready. Holland out.
The most immediately obvious detail about the Saber is the very unrealistic way in which it maneuvers in space. The vehicle pitches and rolls like it's flying within an atmosphere using lift generated from its wings, when presumably we are now at an altitude where the atmosphere is no longer thick enough for the minimal wings of the Saber to generate lift. This isn't to say that it's impossible for these maneuvers to be performed though. With enough reaction control system thrusters and a sufficiently advanced control system, we could perhaps suppose that the orbital defense modifications to the Saber are performed in such a way that its flight performance characteristics are similar to what the pilot would see when flying within an atmosphere, enabling the pilot's skills to more effectively transfer from flying in air to flying in space. Unfortunately, this also does not seem to be the case in-game, since there does not appear to be any sort of reaction control thrusters with which the aerospacecraft could maneuver. Instead, all we have are the aft-facing thrusters and afterburners, which, while definitely possible of providing yaw maneuvers, would be insufficient for pitching and rolling without thrust vectoring, or the ability to aim the thrusters in a different direction. Even in that case, the primary output from these thrusters will still be pointed aftwards, meaning that the vessel will be required to continue traveling forwards even as it's performing these maneuvers. Again, this would be more similar to atmospheric flight, but it does perhaps remove the technical and tactical benefits of being able to reorient the spacecraft in place. It could be possible that the Saber could use reaction wheels or control moment gyroscopes to reorient itself, but at the operational velocities of the vehicle, these would likely lead to significant wear on these reaction systems, which would reduce their functional lifespan. These devices will become relevant shortly though, so we'll discuss them in more detail then. Also, in the absence of forward-facing thrusters, the spacecraft would not have any means of being able to slow itself down. This introduces us to a peculiarity of orbital dynamics encountered by space vehicles. Assuming that everything we see in-game is actually orbiting Reach, as in being under the influence of both its own inertia and the gravity of the planet. Whenever you're orbiting a planet, as you do, your altitude is dictated by your velocity, since you're essentially falling continuously around the planet. And so you need to maintain a constant velocity to maintain your orbital altitude. This also means, though, that if you slow down, you'll begin to be falling closer to the planet, and thus your altitude will decrease if your velocity decreases. Likewise, if you speed up, you're going to increase the height at which you're orbiting the planet, since you are falling slower around it. Basically, if you slow down, you'll go lower, and if you speed up, you'll go higher. As a result, on approach to the ISS, for example, spacecraft have to make a series of hops in order to align themselves with the docking systems at the ISS. So in addition to balancing the non-existent maneuvering thrusters on the Saber, the control system of the vehicle would also have to take into account this unique phenomena of orbital dynamics. We also see that the Saber is equipped with afterburners of a sort, which can be used to increase the vehicle's velocity at the expense of additional heat. Since we're still in space, we do have to assume that the vehicle is still carrying its own propellants, which would also be expended more quickly while firing the afterburner. But for gameplay purposes, the propellant capacity of the vehicle isn't a concern during the level. Now this brings up the fairly major question of how the spacecraft is being cooled. An often overlooked part of space engineering, at least from a popular science perspective, is how you're going to be able to cool your equipment once you get it into space. So time for a quick thermodynamics lesson on that subject. There's only 3 different ways which you can transfer heat: conduction, convection, or radiation. Conduction is between solid objects, and convection is with a fluid. The vacuum of space is neither of these things, and so we have to rely on radiative heat transfer in order to cool things in space. The ability for a surface to transmit heat away from it is dependent on its surface area and the temperature of that surface. In the real world, we also have to consider emissivity of different surfaces, but for our purposes here, we don't really need to worry about that. What this means is that if you want to increase the rate of heat transfer for an object in space, you either have to increase its temperature or its surface area. And this essentially comes down to design choices. You either have to increase the temperature at which you're operating, potentially running into challenges with material compatibility or compatibility with other hardware, or you have to add additional surface area to the radiator. Oftentimes, doing this requires adding additional mass to your spacecraft, which is not great from a launch perspective. You can technically increase heat transfer by adding a different coating that would increase the emissivity of the surface, but this isn't as significant of a contribution as these other two factors. The overall point of this is that cooling things in space is generally more difficult than cooling things within an atmosphere. Now, it is still certainly possible to use other systems, such as a liquid cooling loop, to translate heat from one part of the spacecraft to another, which is done on the ISS, for example, but that heat will still remain on the spacecraft until it is emitted from the radiators. The topic of space cooling also has important design implications for orbital data center equipment, but this is beyond the scope of this video. And so the Sabre would benefit, and most likely require, a specialized thermal control system to draw heat away from the thrusters, especially when they are overheated intentionally, and expel that heat through a specially designed radiator. This thermal management system would also be responsible for dissipating heat generated by weapon systems on board the spacecraft. This is certainly not impossible with the design we see in-game, but depending on the material properties of the outer coating, it could require the vehicle to operate at a higher overall temperature, with potential implications for the crew. Before we get into our discussion of the primary space station of this level, it is worth mentioning the orbital construction platforms that we also see within its vicinity. Now, historically, all space vehicles have been manufactured with one of two processes. They are either fully assembled on Earth and launched into space, or they are designed in a modular fashion, with multiple modules being launched into space and then assembled in orbit. To be technical, we could further expand this list to include space station modules that are launched and then outfitted fully after launch, but for our purposes, this essentially falls into the category of modularity. What we see in-game with these orbital construction facilities is the ability to manufacture space vehicles in space without needing the vehicle itself to be launched. Perhaps one of the most significant impacts of this manufacturing process is that the completed vessel does not need to be capable of launch from a planetary surface. Thus, its mass and exterior design are not impacted by launch considerations, such as payload mass capabilities and aerodynamics. Space vehicles constructed in this manner would not even necessarily need to have their own propulsion system, or at least not one that is capable of launching from a planetary surface. This also means that the size of space vehicles that can be constructed can be much larger than what would necessarily fit in a single launch vehicle, and even individual modules of a larger assembly could also be made much larger. A significant trade-off of this manufacturing process, however, is logistics. All material that is going to be used to construct these vehicles will either have to be launched from a planetary surface or collected from in-space sources such as asteroids, although this second process would likely require more refinement capabilities, so we'll just consider launch logistics for now. The extent to which in-space manufacturing is going to be offloaded from Earth would determine the amount of infrastructure required to finish the manufacturing process in orbit. For example, if you were to just be launching steel stock up into space, then you would likely need some sort of machine shop in space in order to convert that raw material into a finished product. You would also need to consider storage for both finished parts and raw materials that will be used to produce them, versus a more traditional approach, such as was used with the International Space Station, of manufacturing modules and components on the ground and then assembling them once they get to space. Presumably what we see in-game is somewhere between these two options, given the large scale of the vehicles being manufactured, but also the comparable size of the construction platforms to the ships that they're constructing. In-space manufacturing also has the benefit, mostly, of zero gravity. This would make handling of especially large objects much more feasible and also probably require less material handling equipment. This has pros and cons for more base-level manufacturing operations, though. At a very small level, manufacturing of crystals in space is benefited from this microgravity environment, since the crystals can be grown without imperfections that would result from gravity. At a slightly larger scale, though, the lack of gravity could cause difficulty with manufacturing operations that produce chips or sparks, which would not be as easily contained with the absence of a strong gravitational pull. Of course, none of this analysis has been considering the artificial gravity capabilities of the UNSC, which could perhaps simplify a lot of these logistical challenges, but would also potentially result in the outmoding of in-space manufacturing, since artificial microgravity environments could be produced on a planetary surface, and large vehicles could be lifted into space as long as enough energy energy is available to power the anti-gravity system. A generous application of this technology could perhaps allow for much larger in-space manufacturing processes to be performed, which could further explain the presence of the many large starships that we see in the game. However, for the sake of preserving the integrity of the overall futuristic setting, this does seem like a situation where we don't want to overly rely on our miracle exception to explain what's happening in the game. To this end, we might note that the economic costs of artificial gravity systems being used to launch hardware into space might outweigh the lower total costs of in-space manufacturing. And in that case, while it might be possible to just lift everything into space with anti-gravity, it might not be economically feasible to do so. At this point, we're starting to veer off into world building more than engineering, but it's still an interesting angle to consider. So now that we've covered some background on the other space vehicles we see in this level, we can get to what I would consider the most interesting space vehicle, the Anchor 9 refit space station. Now I do think it is important to point out that while yes I am a space station engineer, the design of this space station is much different than historical ones that have orbited Earth. As we just discussed with in-space manufacturing, it is most likely that a lot of the modules or components of this space station were manufactured in space and then assembled in space as well. That is, even if there is any sort of modularity going on with the design of the space station, since it seems to be much more monolithic in design, with less ability for individual components to be swapped out or replaced over time. This could potentially lead to some challenges in the event that any part of the space station is damaged or exceeds its rated lifespan, but it is also worth considering that this space station is a much larger scale than any other space station that we've seen over Earth. Judging by the size of the ships that are docking with it, the station appears to be at least 1 kilometer wide and tall. From this size, we can also ascertain that many of these components would not even fit aboard one of the vehicles that we see docking with the station. It is therefore probably more likely that this space station is designed to be repaired instead of having parts replaced, more akin to a monolithic building that we would have on Earth than a modular vehicle like the International Space Station. This doesn't mean I'm conceding to the civil engineers just yet, as there are a lot of space architecture topics we can still investigate with this particular space station that are very much still applicable even if it isn't the traditional style that we've seen over Earth. One of the most important architectural elements of the space station we can define first is the ground plane. Essentially, this is the definition of down on the space station and where the floor will be that personnel will be walking on, since we have artificial gravity involved. The presence of artificial gravity does sort of expand our possibilities here, but we do see that the inside of the hangars, at least on the space station, are oriented such that the ground plane is aligned with that of the planetary surface. That is, down is in the nadir direction, which is pointing towards the planet below. This is consistent with past space stations over Earth and provides a bit more familiarity for astronauts knowing that down is still towards the ground. If we were to utilize a consistent ground plane across the entire space station, then the towers of the space station would effectively resemble space skyscrapers. Now, since we do have artificial gravity involved here, we could technically redefine the ground plane within these towers such that down was either towards the forward or aft direction of the station, which could allow you to walk along the length of the tower instead of needing some sort of elevator to traverse it up and down. This is probably dependent on the capabilities of the artificial gravity system to produce localized gravity fields, or if the artificial gravity produced by the station envelops it entirely with a consistent downward direction throughout. If this were the case, we might run into some trouble with other space vehicles that are alongside the space station that enter within this gravitational sphere of influence, where the station's artificial gravity might be influencing the gravity on said vehicle, which could potentially lead to uncomfortably high gravity fields on board that visiting spacecraft if it has its own artificial gravity as well. Since we don't have a ton of information about the specifics of the artificial gravity systems being employed here, this is necessarily going to have to remain somewhat open-ended, but it's at least some food for thought when you're designing your own artificial gravity space stations. In one corner of the station, we see 4 extremely large storage tanks, presumably containing fuels for fusion reactions. I think it's probably fair to disregard the possibility that these could be chemical propellants, since at this scale, fusion energy is probably going to be the only feasible method of powering and propelling these massive space vehicles, but also because you really wouldn't want to store this much hydrogen and oxygen so close to each other in multiple massive containers that are probably big enough to blow up the whole station. The size of these containers also suggests that they were manufactured as part of the space station rather than brought up by a ship, considering that they are actually comparable in size to many of the space vehicles we see in-game. That being said, these fuel tanks do appear to be designed in such a way that they can be removed and stored in a sort of magazine fashion, which would be helpful for allowing the station to be refueled from fuel tankers that would be capable of carrying either this amount of volume and mass of fuel or from carrying these entire canisters themselves. Another potential concern here is that these fuel tanks don't necessarily appear to be especially armored or protected from orbital debris. Now granted, at this scale they probably are thick enough that there's less likelihood that an impacting micrometeorite or orbital debris piece would actually puncture one of these vessels, but in the event of a collision with another spacecraft, for example, there's not a whole lot protecting these vessels from being ruptured. However, if we consider that these tanks probably contain fusion fuels, this is most likely to mean that it is either helium-3, deuterium, or tritium. Helium-3 is a noble gas and thus not very reactive, while deuterium and tritium are both isotopes of hydrogen, which is reactive. Tritium is also radioactive on its own, so you might have some concerns with radioactive fallout within space if you were to puncture one of these things. With that in mind, it might be worth adding some additional shielding to these tanks in the event that a spacecraft were to have a missed docking approach, or to prevent enemy vehicles from crashing into them. It is also probably worth noting that there does not appear to be very much in the way of solar power generation capabilities on this station, and while it is unlikely this would be sufficient to power the station at full capacity if the fusion reactor were to go offline, it would still be beneficial to have at least some level of backup power generation capability in the event that fusion power became unavailable for any reason. One of the other most obviously notable features of the space station's exterior is the large number and size of antennas throughout the space station. Now, as I mentioned earlier in this video, antenna physics is definitely not my specialty, but I have worked on integration of antennas on the exterior of a space station before, so at least we have that. As far as quantity goes, it is possible that a lot of these antennas are intended to be redundant in the event that any of these antennas were to be damaged. Another possibility could perhaps be that these antennas are tuned for very specific frequency bands, and so each antenna is needed to communicate on that specific band. It is also interesting to consider the size of these antennas in relation to the rest of the station, which would seem to indicate that at least some of these antennas are used to communicate on very long wavelengths, or equivalently vary to extremely low frequencies. It could also perhaps be possible that some of these antennas are used for phased arrays, which is almost black magic levels of antenna physics to me, a mechanical engineer. But this basically involves using multiple antennas close to each other to produce an electromagnetic interference pattern that results in a more directional signal. Finally, considering that a lot of these antennas are monopole or perhaps dipole in design, they would be much less directional than parabolic antennas like you would see on a satellite dish. This might be beneficial for communicating within the planetary system itself, but could perhaps be less effective at long-distance or interstellar electromagnetic communications. Finally, a perhaps more advanced technology that could be employed by these struts here could perhaps be for power generation from the electromagnetic field of the planet itself. This has been demonstrated in some in-space experiments, but is most likely not anywhere near the power output from a fusion reactor. The inverse of this approach could perhaps be used for tether propulsion, wherein the tether produces a force based on its interactions with the planetary magnetic field that could be used to adjust the station's heading, which could potentially be very beneficial for a station of this size. On this particular topic though, I will mention that if anybody watching has more experience in antenna physics than I do, please feel free to correct me in the comments. Rather peculiarly, we don't see any sort of obvious propulsion systems that would be used to propel the space station, especially considering the immense mass of the station compared to even the large battleships that are docked with it. The propulsion system would also likewise probably be more noticeable than wherever it might be in-game. Now, this is perhaps a less commonly understood element of space stations, which is that once you have them in orbit, they don't just stay up there indefinitely. While it might take a long time for orbital decay to occur, the station is still technically falling around the planet that it's orbiting. As the station passes through these small amounts of particles within the outer atmosphere of the planet that it's orbiting, it will gradually lose velocity due to impacting these many particles. Granted, there aren't as many air particles as there are in the atmosphere, but with an appreciable surface area, this effect does add up over time. An interesting example of this is the International Space Station's solar array wings, which it can maneuver and orient in different positions to control the drag force on the space station, which can be helpful for changing its orbital altitude. As a result of this orbital decay, you do still need to have propulsion systems on your space station in order to keep it up indefinitely. Past space stations such as Skylab that lacked propulsion systems are only able to stay aloft as long as orbital decay will allow. And while the International Space Station, for example, does have built-in propulsion systems on the Russian side of the station, it is also possible to use propulsive capabilities of visiting vehicles to a space station to boost it to a higher orbit, rather than needing the propulsion systems to be on the station itself. With this in mind, we could perhaps say that Anchor 9 is capable of maintaining its orbit with the assistance of a docked spacecraft, but if this is going to be done with the docking system that we see in-game, this is probably not the best idea, since this would produce a significant moment about this docking bridge, which would be liable to shear the whole thing off. Now, even with its own propulsion systems, the station would also probably benefit from having attitude control systems, such as control moment gyroscopes or reaction wheels. These are mechanisms used to change the heading and orientation of a spacecraft by producing a torque or moment that results in the opposite motion of the space station as a whole. In order to make this work with a station of this size and mass, however, you would need to have some pretty significant CMGs on board. And so perhaps a better implementation of this capability on the station could be with numerous smaller reaction control thrusters, which would be used to produce thrusts that result in moments that result in reorientation of the station as needed. Alternatively, a large number of smaller CMGs could perhaps be used to produce control moments throughout the whole station, which could perhaps alleviate some of the space requirements. A smaller factor to consider with the space station that is nevertheless worth mentioning is accessibility on extravehicular activity, or EVA, on the station's exterior. Now, this is a sort of complicated situation here, since we are considering that there is an artificial gravity field in place, which could potentially complicate microgravity navigation along the exterior of the vehicle. That is to say, if gravity is still present outside the space station, then you would have to make sure you don't fall off the tower as you're climbing down it on the outside. On the flip side, this could perhaps allow you to use more traditional methods, such as ladders or elevators, to access places on the exterior, but nevertheless, it does still complicate our analysis. Now, I'm sure one of the first things that will come to mind when I talk about EVA accessibility on a futuristic space station is magnetic boots. And yeah, that sounds cool and all, but what happens when your power source runs out or one of your boots malfunctions? In that case, you might be able to get away with a jetpack of sorts, which has been used on a fair few spacewalks in the past, but this then leads to the risky scenario of being untethered to the space station and floating in space around it. So in that case, you better have a very reliable jetpack to operate. And so the most reliable means of allowing a spacewalk to be performed is with handrails. This approach allows you to have a good amount of control over your position on the exterior of the station, and also allows you to continuously tether yourself to the station as you move along it. The downside to this is that you are limited in your ability to access external parts of the station to those EVA translation paths afforded by the handrails. So in the absence of magnetic boots, jetpacks, or robotic arms, it's going to be difficult to reach those spots where there's no handrails. Also, if like me, you read through some of NASA's requirements for their handrails, you also have to be sure to not place external components near the handrails where they could potentially injure astronauts or be damaged by astronauts. You also might want to avoid getting too close to the giant radiating antennas that are also located on the exterior of the station. After some time to warm up and repower its systems, we see that the station has pretty extensive defense capabilities in the form of point defense cannons. In addition to defensive capabilities, these weapon systems would also potentially be useful for destroying incoming orbital debris that could potentially damage the station. However, it is also worth noting that firing these weapons would produce significant amounts of vibration and other forces on the station that would have to be accounted for by the station's propulsion or attitude control systems. While vibrational isolation could be employed to reduce these effects, the station's control systems would still need to take them into account. Remarkably, this was actually a factor in the operations of the only known space station to carry a weapon into space, the Soviet space station Salyut 3. This vehicle carried a machine gun for ostensibly self-defense purposes, but it was only test-fired after all the cosmonauts had left the station to avoid any potential harm to its occupants due to vibrations produced by the gun. Granted, this is a pretty different scenario than what we see in-game, but I always find it interesting to mention this when I get a chance.
Anchor 9er to UNSC ships, all targets neutralized. Bravo 029er, you are clear to dock. Activating marker.
Holland to Bravo 029er. Noble 5, you ready to go?
Affirmative, Colonel.
Finally, we can consider Anchor 9's interactions with docking visiting vehicles. At the very least, we see that the station is capable in-game of docking with Paris-class frigates and hosting the Sabre aerospacecraft within its hangar bays. Now, this latter operation is perhaps the easier of the two to accomplish. From a radio callout we hear during the level, we can deduce that the hangar bay entrances are facing the forward direction of the station.
Anchor 9 to Sabre teams. Phantom signatures detected on a forward-facing vector.
Now, while the maneuverability of the Sabre does perhaps invalidate some of the traditional restrictions of orbital dynamics that will be used in docking, the rendezvous of the Sabre with the station would still benefit from the relative simplicity, emphasis on relative, of docking with a forward-facing port. Now, there are basically three ways a spacecraft can dock with a space station. These are with an approach on the R-bar, V-bar, or Z-bar. An R-bar approach means that the vehicle is approaching from the R-bar direction, which would be above or below. V-bar approach would mean that the vehicle is approaching from either the forward or aft in the direction that both vehicles are traveling. And Z-bar approach would be approaching from the side, either port or starboard, which is more difficult to accomplish than either of the other two options. With that in mind, the hangars on the forward side of the station would be a much easier target for the Sabres to access, while the starboard docking bridge would be a more difficult target for spacecraft to dock to. We do also see another spacecraft near the propellant tanks, but this one appears to be either damaged or incomplete, and so is not necessarily docked to the station at this location. Once the Sabre has reached the forward-facing hangar, though, it would presumably suddenly encounter the gravity environment of the station, which could potentially be beneficial depending on its flight control systems. Although, since we mentioned earlier that the Sabre doesn't really appear to have any sort of reaction control thrusters, they might still have some trouble actually landing there. Now, historically, in order for spacecraft to dock with each other, they need to perfectly align before interfacing their docking systems together. An alternative approach to this is to use a robotic arm to grab one spacecraft and attach it to the other. This is the approach used at the ISS for some of its visiting vehicles, and in-game we can see a somewhat similar method being used to capture the Sabre once it approaches the hangar. This has pros and cons over docking, but at the very least we can see that the robotic arm capture system utilizes multiple arms to capture the Sabre, which could perhaps allow for improved redundancy. And now, with all that said, we can finally move on to the next sequence of this level, where we can begin the attack against the Covenant supercarrier, as well as get our first glimpse of the second miracle exception in the game.
I'm out here, 6.
Warning. M-Spec re-entry pack disengaged.
I need your override.
Warning. M-Spec re-entry. Cockpit depressurization complete. Canopy release lever armed.
Max Sabadov Siba.
Noble 5, please repeat.
Pull up surface grid 19 by 22.
Gladly. Only sword base, sector 18G.
Thermal enhance.
Noble 5, your pulse is elevated. There is nothing you can do for Dr. Woolsey and the others inside sword base. The mathematics are determinate. Noble 5?
I know.
Bravo, United cleared to re-engage thrusters. Noble 6, this is Holland.
Go ahead, Colonel.
We've flagged a Corvette-class vessel on the predicted docking track with our target. Get our makeshift bomb on that Corvette, and we have our delivery system. Noble 5 will escort the bomb. I need your Sabre team to clear the way for boarding.
Understood, Colonel.
As she's already donated her slip space drive to the cause, the Savannah will be joining you to provide local fire support. UNSC Savannah. Our wings may be clipped, but we've got your back. I've stuck my neck out for Noble on this one, Lieutenant.
We'll get it done, Colonel. 6 out.
Target Corvette sighted within visual range of nav beacon RA-15.
We have visual. Target confirmed.
While the Covenant Corvette is utilizing alien technology that we don't necessarily have a good understanding of, we do at least know that it is operating under the same laws of physics as the rest of the UNSC vehicles, so we can make a few observations in that regard.
Solid copy. We are currently jamming the Corvette's comms. Hit it hard while it can't call for help.
Based on our previous discussion of radio jamming, we can deduce that the UNSC Savannah is attempting to jam the Covenant Corvette by emitting very large amounts of electromagnetic noise. Unless the UNSC is aware of the specific frequencies that the Covenant vehicles use to communicate, the best approach in this instance would probably be to attempt to overload all frequencies that could potentially be used for communication, except for the ones being used by UNSC ships. This would necessarily, though, leave the Covenant able to communicate on those same frequencies as the UNSC. If this jamming signal was going to be spread over the entire electromagnetic spectrum that could be used for communication, including the frequency used by the Sabres, then theoretically it could still be possible for the Sabres to communicate if they were capable of sufficiently high amplification of their own signals. But given the potential communications power output of both the Savannah and the Covenant corvette, in order for jamming to be effective at this scale, any signals produced by the Sabres would most likely be lost in the noise, unless they had an extremely overpowered communication system on board. This would then seem to imply that unless the NMSC has the specific frequencies being used by the Covenant, they can't necessarily guarantee that the vehicle is not able to communicate.
Echo 2 to Savannah Actual. Where are the reinforcements coming from? I thought the target was jammed.
Must be squadrons coming back from patrol, Echo 2.
Don't let any of them get away, Sabres. Kill them before they bug out and warn that supercarrier what we're up to.
Likewise for the Covenant Banshees and Seraphs, unless their onboard communication systems have sufficiently high power amplification, their communication capabilities are also going to be most likely lost in the noise. However, since the intensity of the jamming signal drops off exponentially, the further away the fighters can get from the Savannah, the less intense the jamming noise will be.
I want to clip her engines, Colonel. See if we can slow her down.
Good thinking, Savannah. That'll make boarding her a whole lot easier. Noble 6, I'm marking targets. Take out the Corvette's main engines.
When we first encountered the Covenant corvette, its trajectory has it aiming towards the Covenant supercarrier off in the distance. That vehicle, however, is facing a different direction than the Covenant corvette. While it is technically possible that the Covenant supercarrier and the corvette could be on the same orbit, and the supercarrier is yawed around over 90 degrees, this seems unlikely given the massive size of the carrier and how difficult this might be to actually accomplish. What's more likely here is that the corvette is changing orbits to match that of the carrier off in the distance. This is also important since if the vehicles were to continue on their current paths, the corvette would likely end up behind the supercarrier. Now in that case, it might still be technically possible for the corvette to suddenly shift orbit to match the supercarrier, but this would be a very expensive maneuver in terms of propellant, if the vehicle is even capable of providing that much thrust. And so it would make more sense to try to line up the two vehicles on an approach trajectory that intersects somewhere in the future of both orbits. This means that damaging the Corvette's engines is perhaps a risky maneuver here, as if the Covenant corvette is not able to achieve the delta V required to match this orbit, it may not be capable of rendezvousing with the supercarrier. Although in the immediate term, while the Savannah is still in pursuit of the corvette, it does make sense to try to slow it down in order to overtake it. However, presuming that again that we are following orbital mechanics here, the corvette is already moving at a significant velocity, and disabling its engines would not necessarily reduce that velocity, but instead would allow the Savannah to overtake it by accelerating to a higher speed. Now this is dealing with some more advanced orbital dynamics here, and again, this isn't really my specialty, so please feel free to correct me in the comments if I'm messing anything up here. The overall point of this, though, is that in order for the two spacecraft to rendezvous, they have to be in the same orbital plane to begin with. And it's a lot easier to line up the planes at a more gradual approach than a hard turn once you're behind the other vehicle. Once we finally get around to landing on the Covenant corvette, we are again reminded of the absence of maneuvering thrusters aboard the Sabre, despite its highly controlled flight pattern on its final approach. To some extent, we could perhaps explain this as interaction with the gravitational field produced by the corvette, but even still, the Sabres do appear to still lack the necessary thrusters in order to actually perform these maneuvers to set down gently. Also, after boarding the corvette, we see that the other Marines that have joined Noble 6 do not appear to be wearing any particular form of spacesuit outside of their normal flight suit and an airtight helmet. They also appear to be lacking external supplies of oxygen, although we could perhaps suppose that if the corvette has an atmosphere internally, the Marines' helmets could perhaps be equipped in order to scrub out oxygen from that atmosphere and to make it breathable. They still wouldn't help you in the vacuum of space though, which would also pose a hazard to your body's skin without a pressure suit. Essentially, the problem here is that when we are within an atmosphere, your whole body is being compressed by the weight of the air above you. So it has an internal pressure that balances out that force so you don't feel anything. When your body is exposed to the vacuum of space, however, the pressure inside your body is greater than outside. Now your skin is still pretty stretchy, so it's not like you're going to explode, but due to some unfortunate instances, we have seen cases where exposed skin in a vacuum will swell up significantly. So to counter this effect, spacesuits have to provide this pressure to counteract the internal pressure of the body. Nowadays, this is usually done with a pressurized suit that has air inside it at atmospheric pressure, so you don't feel any different than you would on Earth. But it can also be done with a mechanical counter-pressure suit, which uses the resistance of the material of the suit that you're wearing to provide resistive pressure on the surface of the skin. The result is more sleek and less bulky than the pressure suits that are worn nowadays, but the reason these aren't used anymore is because they are very difficult to actually equip, for one thing, and also because it is difficult to ensure that the pressure of the suit is evenly distributed over all of the various contours of the human body. In the future, though, this technology could potentially allow for more sleek spacesuits than what we see today, which could potentially fit underneath or as part of a flight suit.
Body keg is aboard, Colonel.
Copy that. 6, get your fire team to the bridge. The Corvette's refueling run with the supercarrier will have to be initiated manually.
Yes, sir.
5, stay with the bomb. Discourage the curious.
My pleasure. Hear that, Lieutenant? I'll be all by my lonesome back here. Make it quick, would ya?
Now yes, we will be getting to that Chekhov's gun in a moment, but for now there's a few more things we can look at while we're on the Corvette before we do. For one thing, the destruction of the UNSC Savannah seems to indicate that the Corvette is currently accelerating, since the wreckage of the ship appears to fall behind after the explosion rather than continuing forward at the same pace as the Corvette. It also appears to drop in altitude fairly quickly, suggesting that the Corvette is still gaining altitude as it's increasing its velocity, which is consistent with orbital mechanics. Or perhaps this could also be due to lingering artificial gravity effects on board the Savannah, wherein the residual downwards pull on board the ship could result in the vessel wreckage being pulled downwards towards Reach. Upon reaching the bridge of the Corvette, we see a holographic projection of the Covenant fleet over Reach. Now, using this data, it could theoretically be possible to deduce some orbital parameters of the Corvette and various other vessels that we see in the game, and you're welcome to do so if you really want to. However, at this point I think we've allowed ourselves enough uses of our miracle exception of artificial gravity to make it difficult to actually properly apply consistent orbital mechanics throughout everything we see here. Also on the bridge, it is usually rather convenient that human operators are able to understand alien languages well enough to actually operate their vessels. But in this case, we could perhaps suppose that the UNSC has investigated Covenant technology for long enough that they may have been able to translate the language sufficiently for Spartans to be able to learn it. That being said, it does still seem rather unlikely that the Spartans would receive sufficient training to be able to pilot a Covenant Corvette. I suppose we could attempt to rationalize this by supposing that the Covenant Corvette might utilize an AI system to assist its pilots, and so perhaps the AI could be hijacked to allow a human operator to take control. This may not be the most foolproof plan, but if alien AIs are anything like modern implementations, it wouldn't seem too impossible.
Well done, Noble 6. Uppercut initiated. Corvette is underway.
There is a point to be made regarding the mass of the Covenant supercarrier, which the Halo Wiki gives as 152 billion tons. This is surprisingly close to approximately 10% of the mass of the Martian moon Deimos. This amount of mass suddenly appearing within orbit of Reach would no doubt have a near immediate effect on the other planetary bodies within the solar system, which could certainly be detected by astronomical observations. This implies then that the Covenant supercarrier is using some form of anti-gravity to mask its gravitational signature upon arrival to Epsilon Eridani, as otherwise it would be quite difficult to hide a vessel of this mass even if you are able to cloak it optically. However, we could also note that we don't necessarily know how long the supercarrier was within the Epsilon Eridani system before being discovered, and it could simply be possible that the UNSC didn't have enough time to distinguish the gravitational changes in Epsilon Eridani as being the result of the arrival of the Covenant supercarrier. Here we have finally reached the point where we need to invoke our second miracle exception for this series in order to explain the faster-than-light transportation technology utilized by the UNSC, the Shaw Fujikawa Translight Engine. Now once again, I'll be using the Halo Wiki as the basis for the explanation here, but it's also worth noting that a lot of the information on the Halo Wiki regarding this topic is pretty nonsensical in terms of physics. However, there is enough information available to give us a general idea of how these systems work, which we can expand upon using actual, or at the very least theoretical, physics to explain how this transportation system operates. I do have to give the designers of this system some credit too, as this is the first time I've seen this sort of technology being utilized for faster-than-light transportation. The translite engine is stated to operate by creating a microscopic black hole, which the engine then manipulates into forming a rupture between four-dimensional spacetime that we live in and a higher dimensional spacetime known as slipstream space, which has all sorts of random and wacky features that don't really make any sense. On that note, a lot of the descriptions of slip space given on the wiki seem to be intended to indicate that this space is so far above human understanding that it doesn't fit with any of our known laws of physics, and this is very difficult to understand. Or alternatively, that the writers took absolutely no care whatsoever into designing a coherent physics for their higher dimensions. But the point of this analysis isn't on slip space itself, it's about the engine that allows us to utilize it. And in this regard, we have enough information to come up with an explanation that is at least somewhat consistent with a modern theoretical framework of physics. So our explanation of the engine operation would be something like this. The engine generates a microscopic black hole using a particle accelerator. Within the insanely short time that it takes for the black hole to evaporate, the engine feeds the black hole sufficient mass energy to cause the black hole to grow to an appreciable mass energy itself. Once the black hole reaches a sufficient mass, or perhaps as a result of its growth process, it produces a distortion in spacetime, resulting in an opening or unfolding of higher dimensional space, such that it becomes spatially accessible from the four-dimensional spacetime that we're familiar with. At this point, the ship can then utilize its reaction thrusters to fly through hyperdimensional space in the same way it would through three-dimensional space. Presumably then the same mechanism is used to produce another unfolding of higher dimensional spacetime at the exit point in three-dimensional space. At a very basic level then, the Shaw-Fujikawa translite engine can be said to be creating a wormhole entrance from the outside and then creating the wormhole exit from the inside. Now, this concept is not totally without basis in real-world physics, as it has been theorized that microscopic black holes may be capable of forming, under optimal conditions, of extremely high-energy particle collisions. Conveniently, in some formulations of higher dimensional physical frameworks, there is also a reduction in the total energy required to produce these microscopic black holes. Assuming that we could draw from one of these theories our higher dimensions, as well as a relatively feasible energy required for the production of a microscopic black hole, our challenge then becomes controlling the distortion of higher dimensional spacetime with a great enough amount of precision that it can be used to form a traversable wormhole. Of course, we're considering whether or not this is even physically possible, not necessarily the amount of computational power required to do such calculations, which the Halo Wiki does at least mention is a significant challenge to the operation of slipspace drives. Now, all of this has been without getting into details of Hawking radiation, string and M theories, or wormhole physics. But I think without even going that far, we can say that it is pretty clear that we're going to need another miracle exception to explain what's happening here. At the very least, this exception would have to cover the controlled deformation of higher dimensional spacetime that results in the creation of a traversable wormhole. Although, if you were able to distort spacetime in such a controlled manner, you probably wouldn't be too far off from making an LQBR warp drive, which, as we've talked about a lot on this channel, is a potentially much more realistic method of faster-than-light propulsion technology. We could perhaps be generous and say that the technology for LQBR warp drives was invented first, which then led to the further development of the Shaw-Fujikawa translite engine using the associated physics. Now, aside from purely theoretical physics, there's actually some very interesting real-world historical tie-ins with some of this technology that correspond with the time frame of the release of the original Halo games that provide us some additional context as to how this technology is implemented in-game. Now first, I have to reiterate that I am not familiar with all of the Halo lore and have not read all of the books before making this review, so if I'm misquoting any sources here or referring to different ones, please feel free to correct me in the comments. However, the timeline of the release of the original Halo games and books closely overlaps with the construction timeline of the Large Hadron Collider, currently the largest particle accelerator in the world, spanning across the border of France and Switzerland. One of the most expensive and massive scientific instruments ever constructed, this machine is designed to, among other things, study particle collisions at energies never otherwise achieved. However, during its construction, concerns were raised over the theoretical possibility that the Large Hadron Collider might actually be capable of producing microscopic black holes. This was, of course, dependent on higher dimensional physical frameworks being accurate, and the mass of these microscopic black holes would be so small that they would evaporate in an extremely short amount of time. But nevertheless, the concept that a machine could generate a black hole was enough to cause a panic in the general population who were looking at this from a popular science level. The first scientific paper I could find on this subject was published in June 2001, which is a few months before the publishing of Halo: The Fall of Reach, which is one of the sources cited on the Halo Wiki for the explanation of how the Sha Fujikawa Translite engine operates. It seems that the technology is explained in more detail in Halo: Ghosts of Onyx, which was released in October 2006, well into the construction of the Large Hadron Collider, and almost 2 years before its first successful operation. With this overlap in timelines, it seems pretty reasonable to suppose that the possibility of the Large Hadron Collider producing a microscopic black hole provided at least some of the basis for the operation of faster-than-light transportation technology in the Halo series. Now, as you can probably tell, if you're watching this video before 2041, or whenever the LHC does end up getting decommissioned, that the LHC has not created a black hole that has swallowed up the entire planet. The concept of a particle accelerator creating a microscopic black hole isn't even the question here, since apparently this may have already happened at a different particle accelerator. And it turns out this was never really much of a serious concern, since at the scale of microscopic black holes that could be produced, they would evaporate extremely quickly to the point where they hardly even have a chance to absorb any mass anyways. And it's possible I may be misremembering some details from my childhood here, but I think this is a little before the time where everybody on the internet became obsessed with black holes and time travel. So this became a situation where people were concerned about the possibility that the world may be about to end as a result of extremely advanced physics that are well beyond most people's reach. Honestly, myself included. The math of this stuff is insane. But a lot of people did take this very seriously, and in some cases had extremely disproportionate responses. And while I would say that it is definitely admirable to research these topics and try to understand them for yourself, these are very advanced topics in physics. But even if you're not studying for an advanced degree in this field, this still seems like a good example of the importance of critical thinking in response to sensationalized news stories. The headline's job is to get you to click on the article, not to inform you on the nuances of microscopic black hole physics. Returning to Halo Reach though, we can throw away a good chunk of that critical thinking, as now we really do want to create a microscopic black hole in order for the slip space bomb to function as intended.
Distance is closing on this vessel's refueling track with the Covenant supercarrier. 76 seconds to endpoint.
So, it's gonna be like that. Well, I got good news and bad news. This bird took some fire and our thruster gimbal is toast, which means the only way off this slag heap is gravity.
And the good news?
That was the good news.
At current velocity, 53 seconds to endpoint.
Yeah. Bad news is, time is fried. I'm gonna have to fire it manually.
That's a one-way trip.
We all make it sooner or later. Better get going, Six. They're gonna need you down there. Listen, Reach has been good to me. Time has come to return the favor. Don't deny me this. Tell him to make it count.
This brings us to the end of this level, but unfortunately not the end of the Covenant invasion.
Slip space rupture detected.
Gamma station control, reading multiple pings below the orbital defense
Slip
grid.
space rupture detected.
Yeah, we're picking up anomalies too. Are you reading
Slip
it?
space rupture
Multiple
detected.
Covenant signatures.
Slip space
Is anyone
rupture
listening?
detected.
They're everywhere.
Slip space
Yeah,
rupture
but
detected.
the whole damn Covenant
Slip
fleet.
space rupture detected.
The next level opens with Noble 6 having reached the surface of the planet mostly intact. While we don't know all of the orbital parameters of his flight in space, this doesn't seem totally far-fetched with the appropriate combination of high-velocity parachutes and deployable atmospheric re-entry shielding. There have been a handful of high-altitude jumps from within Earth's stratosphere, which, while not technically within space, is still very impressive. In the case of Felix Baumgartner's jump, which was sponsored by Red Bull to great fanfare, he became the only person in history to surpass the speed of sound without the use of a propulsive engine. However, this brings up another problem that would be faced by a space dive from outside the atmosphere, which would be aerothermodynamic heating. Since most objects entering a planetary atmosphere will be traveling at least orbital velocity, by the time they enter the atmosphere proper, they can be traveling at Mach numbers of over 25. At this point, we are well beyond the supersonic realm of velocities and have gotten into the upper stages of hypersonic flow, at which point the frictional heating of the particles of air is enough to actually ionize the air into becoming plasma. This heating phenomena is exacerbated by the shape of shocks that form on the vehicle's leading edge, which requires some design modifications from supersonic vehicles. And generally, you basically need to have a blunt surface to re-enter with, which will produce a detached bow shock, reducing the amount of heating present at the surface of the vehicle. Now, in the case of Halo Reach, our vehicle entering the atmosphere is a suit of armor, essentially, with lots of sharp edges that would produce attached shocks and significant aerothermodynamic heating. While we do have shields and advanced materials as part of our equation here, there's probably actually a simpler way to approach this problem considering the re-entry unit that we had before jumping. In addition to a parachute, this backpack could include a hypersonic inflatable aerodynamic decelerator, or HIAD, which is a deployable heat shield that NASA has successfully tested in the past. Since we only need to protect an object the size of a human, the shield doesn't need to be as large as a space vehicle, and so given 500 years of material science advancement, it seems reasonable to suppose that this technology could be miniaturized such that it would fit in a backpack. One other interesting note about this re-entry kit is the inclusion of a magnum pistol. This actually has some historical parallels, as in past space missions, cosmonauts would carry a survival gun with them as part of their space mission. This was the TP-82, a triple-barrel break-action combination gun with 2 shotgun barrels and 1 rifle barrel. Because early Russian space capsules were designed for landing within the Russian mainland, there was a possibility that the cosmonauts could become stranded in the wilderness and have to deal with Russian bears. We can also note that since it is most likely that Noble 6 would be using a parachute to survive re-entry, it would make sense that the Covenant spacecraft would have crashed down before he landed, considering that it would not have any way of slowing its descent. Now, I do want to make a quick note here that these next couple levels involve the city of New Alexandria, where my mechanical engineering proficiency for building weapons would probably not be as useful for reviewing these buildings as the civil engineer's proficiency for building targets. So these will be a bit shorter chapters as a result. Upon arrival, we see that the Covenant is currently in the process of decimating New Alexandria, and our mission objective has shifted to evacuation of civilians. As we'll see shortly, this will introduce some interesting concepts of aerospace travel and its implementation into New Alexandria's city infrastructure.
This is Kilo Dispatch. All available teams advance to Traxxas Tower. The evacuation will commence ASAP.
Copy, Dispatch. What's the status of the tower pad?
Tower pad is green. Let's move these civilians before it changes.
Now, another reason why I won't be reviewing New Alexandria as much detail as some of the other levels is that I am from the middle of nowhere, North Dakota, and these giant cities are very much unfamiliar to me, so it's hard for me to really comprehend how realistic much of this is. I do think it's pretty cool to have such a large outside boardwalk on an elevated portion of the city, but whether or not that makes sense from a city planning perspective is pretty much beyond me. So if you're more familiar with the big city life than I am, I would definitely appreciate you sharing your thoughts in the comments. It's nice to see these automatic doors have some form of safety mechanisms that, in the event of a malfunction, can prevent the doors from violently slamming shut, reducing the possibility for dismemberment of people walking through it. While traversing through the city underbelly, we encounter this dumpster which has an inspection schedule on it for some reason, which has been signed off upon despite this dumpster not actually fitting below the trash chute that is right next to it. Sure, the dumpster itself might be safe, but if you can't actually use it here, then this seems like a bit of an oversight. I suspect there's a joke to be found here, but I'm no Norm Macdonald, so we'll just move on. In one courtyard, we come across a food stand that appears to be serving fast food, sourced from of the local wildlife. On the extended menu, we can also see what appears to be sushi rolls and noodles, which are probably also fairly easy to obtain in this location. Despite the World Cuisine sign above the stand, which is somewhat consistent with some of the food offerings, we also see the banners in this area are labeled with Magyar cuisine, which again is Hungarian. I'm definitely not familiar with this myself, although the heading on Wikipedia suggests that my Scandinavian taste buds might not be well suited for it, but it's cool to at least see another instance of the influence of Hungarian settlers on Reach, even though it doesn't really appear that there is any Magyar cuisine listed on the menu. At the base of the Traxxas Tower, or at least the level we enter it on, there are a number of payphones present in the lobby, as well as in some other places throughout the tower. This seems a bit odd, considering how it is very likely that smartphone technology will continue to evolve over the next 500 years, but again, since I'm not from a big city, I can't really comment on how realistic this is. I would say perhaps an economic explanation could make this make a bit more sense, but there does appear to be a lack of any handset here, potentially reducing the capability for private conversations. Now, in addition to the eternal struggle between mechanical and civil engineers, this part of the level also seems like a place that architects would find interesting. And if nothing else, this is an interesting reminder that the platform of video game design is an opportunity to implement some more advanced architectures that may not necessarily be the easiest to construct.
If you're trying to get to the tower, you're too late, Lieutenant. Corvette over the starport pounded the hell out of the place. Cargo port's impassable on foot, rooftop evacs awash. We could use the executive landing pad, except there's no easy way to get there. A group of ODST specialists are working a plan. They might appreciate some backup.
Now, due to some totally foreseen circumstances, we now have to shift our focus to an executive landing pad on Traxxas Tower. This landing pad is still far below the top of many of the towers in the city, which would necessitate aircraft to be flying between buildings, which would probably pose a lot of additional safety hazards and regulatory compliance issues.
Radio's buzzing about you, Spartan. You feel like jumping?
Quite possibly one of the most fascinating sci-fi technologies in most popular media is the jetpack. It seems like if we're able to put a man on the moon, we should probably be able to use a rocket to fly around on Earth. And actually, yes, that is a thing. There are a variety of functional devices that can be categorized as jetpacks that have operated over the last few decades. Some of the more effective implementations use actual jets, such as the jet suit formerly known as the Daedalus flight pack. Based on their website, it looks like you can just book a flight with one of these, for a nominal fee, of course. This implementation highlights an important design feature of jetpack technology, which is the need for precise control over the user's flight pattern. And so in this implementation, some additional thrusters are used on the user's arms to control their flight direction.
Welcome to the Bullfrog. Other side, on my mark. 3, 2, 1.
Now, there have been implementations more similar to what we see in Halo Reach, which have been achieved with something closer to an actual rocket engine. The best example I could find for this was the Bell rocket belt. This system utilized pressurized nitrogen to force hydrogen peroxide through a catalyst which would decompose it into hot steam and oxygen. These gases would then be forced out through a rocket nozzle to produce thrust. Unfortunately, due to the amount of propellant required to actually produce a sufficient thrust, it could only be used for a couple dozen seconds. But fortunately, it does actually work for that amount of time. While researching this, I also found out that during the lead up to the launch of Halo Reach, they had a group of Spartans doing a promo for the game in Trafalgar Square, London, with one of the Spartans flying in on a rocket belt. Now, if we wanted a jetpack implementation more similar to what we see in the game, we would either need to have a fuel with a much higher specific impulse, allowing it to produce more thrust per unit mass, thus allowing the fuel to last longer. Or we could try to come up with an alternative propulsion source that perhaps utilizes more of the air around you, so that as long as you're within an atmosphere, it has propellant. If we assume that high-density electrical energy storage is by this point a widely available and miniaturized technology, we could perhaps suppose that the jetpacks could use something like an arc jet or resistojet, which utilize electrical heating to increase the energy of their propellants. However, in modern implementations, neither of these options provide very high thrust, and unless you have a pretty significant amount of energy provided to the propellants, it's probably not going to become more effective than a chemical propulsion system. In any case though, the performance of the jetpacks that we do see within Halo Reach is definitely realistic. It's just the recharging of the jetpack that would take some extra effort.
Pleasure jumping with you, Spartan. We'll hold this location. You get on that Falcon. Make sure those transports make it out in one piece.
Approaching the New Alexandria spaceport, we encounter the Egret spaceliner commercial vehicles being used to ferry civilians out of the city.
This is Civilian Transport 6 Echo 2. I need to go now, Sergeant Major.
Hold on, Echo 2. Start with Dawn. I have multiple commercial craft loaded with civilians. I have got to get them out of the city. I need air support now. As soon as something frees up, you'll be the first to... Not good enough.
I've got 600 souls on board, Sergeant Major. I can't wait any longer.
Negative, Echo 2. I can't cover you. Do not take off.
While we're here, we can note that New Alexandria is built on the coast of the Epos continent, which would again be beneficial for helping ensure safe space launches. We might also note that this is a convenient setup for the use of space planes being launched from the spaceport, since these vehicles would most likely produce a sonic boom during their ascent. This was a big part of the reason why the Concorde jet never took off, in a metaphorical sense that is, since it would produce sonic booms over the inhabited land that it flies over, which would be very inconvenient. This is also at least partly why the X-59 Quest aircraft is so exciting, as it is designed to fly at supersonic speeds with reduced, or at least quieter, supersonic booms. The design of this space plane is clearly influenced by modern-day passenger aircraft. Unlike some of the other vehicles we've seen throughout the game so far, this one does actually have wings with an appreciable surface area that could produce lift for use when flying in an atmosphere. It also possesses sizable nacelles, which are presumably using fusion engines to provide spaceflight capabilities. It can also be seen that the vehicle is capable of carrying cargo containers on the nadir side of the vehicle, which can be attached and detached from below. With that in mind, the mass of the vehicle reported by the wiki is greater than any Earth-based vehicle that has successfully flown into space, so we are probably once again having some sort of anti-gravity usage here. Although with this being a space plane designed to operate within the atmosphere, we could perhaps say that it is less necessary than some of the larger spacecraft that we've seen. Unfortunately, this vehicle does have a relatively common design flaw among science fiction space planes, which is the lack of a blunt surface to act as a leading edge upon re-entry. As we discussed at the beginning of this level, the geometry of a vehicle re-entering an atmosphere has to be effectively designed such that it is capable of surviving the aerothermodynamic heating of the re-entry. And in this case, there are a lot of leading edges on this vehicle that would form attached shocks, resulting in extremely high local temperatures. Given the size of this vehicle, I suppose it could perhaps be worth considering that an active cooling system is used to ensure that the surfaces do not overheat excessively on the way back into the atmosphere. This would require a pretty significant expansion of the vehicle's thermal control system, if not its whole own system itself, and the benefit that could perhaps be afforded by this addition could probably be better solved by redesigning the overall shape of the vehicle. Alternatively, the spaceplane could perhaps use retro thrusters to slow itself down upon re-entry to speeds where aerothermodynamic heating is manageable.
Spartan, Sergeant Major Duval. Awful day so far. Let's keep it from getting any worse, huh? Covey's all over my missile batteries, and I got 5,000 civilians across the bay waiting for passage out. I need you to arm those batteries, then fire those missiles from the central terminal. Understood? Corvette's been a pain in my ass for too damn long. Give it hell, Spartan.
Finally, we can make a note about the missile batteries that are used to chase off the Covenant Corvette at the end of this level. Based on their design, these appear to be deployable emplacements, and their presence here is probably not part of the original design for the park. Since the batteries have not been destroyed by the Covenant, we can suppose that they just recently had overtaken this area, and the UNSC was in the process of fighting them back before they could destroy the turrets. As a way to perhaps explain this typical gameplay objective, we could perhaps suppose that the missile batteries utilize a security lockout system, preventing them from being fired unless an approved operator is present, which for missiles of this size is probably a good idea. So after presumably punching in the number 7 repeatedly on both of the missile battery keypads, we can end the level by pushing the big shiny button and saving the day.
Missile defense online. All evac transports, you are cleared for takeoff. Repeat, you are cleared for takeoff. Go now.
Civilian transport away. You saved a lot of lives today, Spartan.
Copy. Repeat, this is Noble 2, Noble 6, Noble 5. Do you copy?
This is 6. Go ahead, Noble 2.
We picked up your transponder about an hour ago, but could not risk open comms. Covenant have the city sealed tight. We're getting nothing from George.
He didn't make it.
Understood. What's the situation at Starport exit?
The last transport is away.
All right. We're bringing you to us.
The next level finds Noble 6 taking to the skies from the concrete jungle rooftops of New Alexandria. Once again, this level will be a bit shorter, since a lot of the level consists of flying around rooftops in the Falcon, and as I mentioned in the previous level, big cities are something I'm not very familiar with, and admittedly this level is probably more appealing to civil engineers or architects.
It's good to have you back. Sorry I came alone. Make him proud.
Put your wings back on, Lieutenant. We're flying this Falcon. Here's the situation. Covenant have deployed multiple long-range comm jammers in high rises across the city. We can't hear Holland and he can't hear us. We're totally cut off. Trooper squads have been trying to take the jammers out, but the coveys are dug in tight. When I confirm targets, I need you to hit them. Hard.
The Covenant jammers have apparently been tuned to specifically cancel out the frequencies used by UNSC communications. This is effectively the flip side of the situation we saw earlier when the UNSC Savannah was trying to jam the Covenant corvette in Reach orbit. While we would probably need to go further back into Halo history in order to determine the details, it's probably fair to say that the Covenant has concealed themselves within the Epsilon Eridani system long enough to identify which frequencies are used by the UNSC for communications so they can know what frequencies to tune their jammers to. The Halo Wiki states that Reach was one of the top exporters of titanium within the UNSC-controlled systems, which is an important metal in aerospace production in modern times, but given a sufficient abundance of the metal, we could perhaps suppose that it might be used within the construction of the skyscrapers in New Alexandria. I would also be very interested to hear from somebody in the construction business about how feasible it would actually be to construct a whole city's worth of these massive skyscrapers so close together. Regardless of the construction processes though, the Halo Wiki indicates that New Alexandria is not even within the top 3 largest cities on Reach, indicating that the infrastructure on Reach was more than capable of supporting this level of metropolitan development. It is also reported that the events of Halo Reach take place 190 years after settlement of the planet, allowing a pretty significant amount of time for construction of these cities. Among these metropolitan spires, we can see a thick layer of fog below us, in addition to a significant amount of cloud cover overhead. Now, obviously, due to the ongoing destruction of the city, the current weather conditions are very far from natural, and so it is likely that this lower level of smog is caused by destruction from the ground level, forming a sort of urban dust dome. It could also be possible that this layer of smog is due to emissions from the ground level of the city, which, depending on the specific district we're located in and when this part of the city was constructed, may or may not be fully running on clean energy sources such as nuclear fusion. We can also see that this part of the city appears to be located at the foot of a mountain, but the rain appears to be falling towards the mountain rather than away from it, if we were to assume that New Alexandria is on the windward side of the mountain, where air flows inland from out on the water over the top of the mountain. Another caveat to all this, though, is that in addition to destruction of the city, these buildings are likely much taller than what we see on Earth, or at the very least, the combined number, density, and height of these buildings is more than we would see in modern cities, which, combined with a general lack of information on the climatology of Reach, might make it difficult to make any conclusive determinations about the nature of urban weather within New Alexandria. All 3 of the buildings in which the Covenant jammers are located have landing pads off the side of their buildings. This would seem to imply the existence and usage of other flying vehicles aside from military Falcons and Pelicans, and in the case of this landing pad being located at a nightclub, probably indicates that it is only used for the VIest of Ps. Alternately, the building could perhaps have been originally designed for a different purpose and then was retrofitted into a nightclub. Also, given the variability of heights of buildings within this area, it's probably safe to assume that air traffic within this space is restricted to sufficiently maneuverable aircraft, and necessarily those that can perform vertical takeoff and landing. In a manner somewhat reminiscent of Independence Day, at least twice during this level, we see the glassing beam fired from Covenant battle cruisers, which are used to destroy the city. One of these battle cruisers moves and maneuvers extremely quickly for its size, which, while probably possible given enough propulsive thrust, is probably also indicative of its use of anti-gravity technology to make maneuvering like this more manageable within an atmosphere. At the very least, this ship does appear to have what could be considered a lifting surface, which along with anti-gravity would probably be required to perform this drift maneuver. From the Halo Wiki, we can learn that these weapons are used to excavate Forerunner artifacts on planets that the Covenant identifies, as well as to perform glassing of planets that the Covenant deems worthy of destruction. This is accomplished by having multiple capital ships fire these beams downwards towards the planet's surface while circling the planet across a variety of orbits. The wiki indicates that this weapon utilizes a directed beam of plasma fired from each ship, which would require a significant amount of source gas to be available on the ship, in addition to an insane amount of energy available to ionize that gas and turn it into plasma. Perhaps a slightly more feasible implementation of this technology, I guess for the UNSC to use if they wanted it, would be to create a laser-induced plasma channel from orbit. Essentially, this would involve firing an extremely powerful laser into the atmosphere, which has enough power to heat and ionize the atmospheric gases that it passes through. The result is a channel of ionized gas, or plasma, along the laser's path. Due to the change in the density of the atmosphere as a function of altitude, it might be difficult to predict how much energy would actually be required to do this, or at least to do it effectively. But if we allow the Covenant effectively unlimited energy storage aboard their ships, this could perhaps be another explanation for how these weapons might operate, or at the very least the glassing beams fired from within a planetary atmosphere. The building in which the second Covenant jammer is located is home to the Synoviet Corporation, which, from one of its product showcase holograms, produces at least some of the components of the UNSC battleships. From the Halo Wiki, we can see that in addition to producing a variety of spacecraft, they also produce other vehicles and equipment used by the UNSC. Now, for some reason, when I first saw the name of this company, my first reaction was that this was a return of the Soviet Union to spread space communism throughout the galaxy, from their giant corporate headquarters on Reach. But perhaps a much more likely explanation is that this is a Sino-Viet company combining the forces of China and Vietnam, which, given that they are manufacturing their warships, are presumably part of the United Nations in the 26th century, and probably not allied with a resurgent Soviet Union. In what is hopefully not a common theme for the entirety of this city, the railings on the walkways within the Synovia Tower platform seem somewhat low even for a human of natural size. This problem is exacerbated by the protrusion of some of these walkways out over the edge of the buildings, providing only minor protection against a fall over hundreds of feet. I suppose one could say that this introduces the concept of the maximum height at which it is sensible to include additional safety precautions to prevent against falls, since perhaps above a certain height it probably doesn't make a whole lot of difference how far you fall. At the very least, we could at least expect the corporate business people within this building to probably be sober while they're traversing these walkways, which could perhaps be a concern for the exterior portion of the nightclub that we saw earlier. In another instance of me clearly being from a small town in the middle of nowhere, is that it didn't really occur to me until I started researching this that elevators would be pretty much essential for buildings of this height, which also probably applies to skyscrapers on Earth. For emergency evacuations in situations such as this, it may perhaps be technically possible to walk down a staircase to the bottom of the building, but that's probably not going to be a timely solution for a serious incident. With buildings of this height, it would probably be wise to have additional evacuation protocols in place, perhaps including a plentiful supply of parachutes. On a related note, the last building in which the Covenant jammers are located is an elevated hospital. Given the vertical scale of the city, it could very well be more efficient to rush an injured person from one of these higher buildings to the elevated hospital rather than attempt to get them down into the congested lower airspace of the city and search for a landing pad at that level. Some of the maps in the hospital also point out the sky bridge connecting it to another building. While I suspect retrofitting the buildings with this sky bridge at this altitude would be pretty challenging, this has actually been done quite a bit within Minneapolis, Minnesota, albeit much closer to the ground, which came in very handy when the city hosted a Super Bowl with a lot of visitors who weren't used to weather with face-freezing temperatures.
Area clear. We're good here, sir. You can head back to your bird.
Look at me. I'm a dead alien. I'd like to vote, please.
It's also worth pointing out that the hospital helipad is much more protected against accidental falls off the top of the building, so it's not like nobody ever thought this might be a concern.
Noble 2 to Noble Leader. All jammers are down.
Solid copy, Noble 2. New orders. All personnel are to be evacuated from ONI HQ. Say confirm.
Confirm ONI Tower evacuate.
Noble 2! Noble 2, sit rep!
Copies are hitting the HQ in force! They must have zeroed my signal!
Get that evac started!
Roger that! Noble 6, get over here and cover our evac pelicans. I need you overhead now!
The landing pad that is deployed from the ONI headquarters building appears to be supported in a purely cantilever fashion. In addition to the significant and perhaps unnecessary amount of torque that this would place on the deployment mechanism, which it would have to be designed to support, this would also have to require a significant amount of space inside the building to be reserved for this deployment mechanism and for the landing pad itself once it's retracted. Perhaps a better implementation here could involve the landing pad folding up or down from the side of the building, using extended deployment mechanisms to support the landing pad.
We got movement. Multiple Covenant vehicles vacating the area. And they're in a hurry.
How often you see Covenant retreat for no reason?
Radiation flare. Big. 40 million root guns.
Just lost Holland. What's going on?
Atomic excitement scrambled the signal. 90 million now.
Source?
Airborne. Close.
How close?
That close!
As a final note for this level, we can point out that the radiation dosage indicated by Cat utilizes a legacy and outmoded unit that is used to define the amount of radiation being released from a certain mass of air. This is necessarily different from the received dosage of radiation that a person might experience, but with the reported levels, this is still likely to produce an insanely lethal dose of radiation to everyone within the city. Perhaps we can suppose that the Spartans' enhanced biology, or their still active shields, could explain how they were able to survive the blast without wearing their helmets, which unfortunately paints the conclusion of this level in another layer of dark dramatic irony.
We get orders from Holland, sir?
We're being redeployed to Sword Base.
Sword? Covenant own it now!
Which is why they want us for a torch and burn op. Keep Dr. Halsey's excavation data from falling into enemy hands.
It hasn't already.
Maybe, but according to Holland, the Covenant are still hunting for something.
Where does he get off calling a demolition a priority one?
Come on, get in!
Let's go, come on!
Noble 1, this is Noble Actual. Noble 1, go ahead. We need that base taken out, son. What's your status? Still outside. Thermal on the interior shows standing room only. We're gonna have to thin them out or we'll be way too popular. Copy that, Noble 1. Holland out.
The next level finds us returning to Sword Base with the ostensible objective of destroying Oni intelligence to prevent it from falling into Covenant hands. About 2/3 of this level takes place over the same map that was used in the second level of the game, so for our review we can speed through this part pretty quickly.
Enemy sighted.
Covenant owns this sector now, but they're defending for a major strike, not a small group infiltration. Eliminate all hostile ground-to-air defenses so the rest of Noble can land at Sword Base for the torch and burn. Keep a low profile. We take them by surprise, this will be a hell of a lot easier.
At the start of the level, we have returned to Farragut Station, the small communications outpost not far away from Sword Base. However, most of the area previously occupied by Farragut Station is now underwater. While it's not specifically stated in-game, since Sword Base is located next to the Bobcatha ice shelf, the implication here is that Covenant glassing operations have begun to melt the glaciers of the planet, resulting in an increase to sea level. It is possible to see below the waterline if you crouch in the right spot, where it appears that the ground level has actually also increased. This could perhaps be due to the settlement of debris that has been shifted from the mountaintops, or it could perhaps just be a gameplay optimization. If we compare the sea levels here with where they were at our first encounter with Farragut Station, it appears that the water level has risen by around 6 to 10 feet, although it's difficult to say for sure. Now this doesn't necessarily mean that the sea level of the entire planet has risen this dramatically, since due to the shape of the ice shelf and the nearby waterways, it's possible that this could just be an increase in local water levels. However, if we refer back to our map of Reach, we can see that Sword Base is located on the coast of Big Crater Bay, which is connected to the Reach oceans by significant sized waterways, which probably means that at the very least Big Crater Bay has increased its sea level this dramatically, and possibly the rest of the planet will be feeling the effects as well. As we saw during the destruction of New Alexandria, the Covenant is firing extreme amounts of plasma into the atmosphere of the planet, and while most of that thermal energy is transmitted into the ground, a significant portion of it, depending on the efficiency of the plasma beam, will be dissipated into the atmosphere directly. This is effectively analogous to dumping stellar material directly into the planet's atmosphere, and as a result would probably be a very effective manner to speedrun a climate catastrophe. During this level, we finally encounter for the first time the Scorpion main battle tank. Now, while there's probably a lot that could be said about this vehicle in particular, one of the more interesting details that stuck out to me when researching this is that the tank is apparently powered by electrical batteries that are recharged using a hydrogen turbine. This is in contrast to many modern tanks that use diesel fuel, which is probably not as plentiful as hydrogen throughout the galaxy, and has a lower energy density than hydrogen. However, diesel does have the benefit of being easier to store than hydrogen, and despite its energy density per unit mass being lower than hydrogen, its energy density per unit volume is higher. With hydrogen, the energy density could be improved by using a cryogenic storage system, but then you have to deal with a cryogenic storage system. And in either case, the hydrogen will be stored at a higher pressure than the diesel fuel. However, from an economic perspective, the relatively plentiful presence of hydrogen throughout the galaxy is probably going to result in a win over diesel when it comes to the final design decision.
Nice job, Six. Falcons, commence descent. Meet you inside the base, Lieutenant.
It appears that after taking over Sword Base, the Covenant was not willing to take the time to correct Oni's mishandling of liquid fuel storage by leaving it unprotected on their front lot. So as part of our Space OSHA inspection, we can ensure that nobody will be injured by these tanks in the future. I mean, just imagine how much money we just saved Oni by preventing lawsuits.
Where are we going now, boss?
Dot. Please proceed to the pre-arranged coordinates.
In a manner more reminiscent of the Dead Space universe, this security door is probably more overcomplicated than it needs to be, but perhaps we could suppose that the central block and sliding sides of the door are simply very heavy objects that are used to prevent enemy personnel from forcing the door open. The door also doesn't really appear to slide into any particular slot in the door frame, but of course, especially in this low lighting conditions, this is clearly just a gameplay optimization. After fighting through the remnants of Sword Base and reaching the provided coordinates, we can transition to the part of this level that we did not encounter previously, as the urgency of Noble Team's mission increases dramatically.
Looks like they got themselves cornered.
Or we're committed to the position.
I'm going with cornered. There's nothing here.
No load-bearing columns either. Sir, if we're supposed to blow this place, this ain't the spot to do it from.
Dot, check your vector.
Vector confirmed, Commander. We are precisely where Oni has directed. Apologies. Coordinates revised. Please confirm?
Revised?
By an AI of unknown origin, whose clearance is well above my own.
Well, it's pointing us a click and a half east and 2,000 feet underground.
I didn't bring my shovel, Commander.
Sir, I say we go AI free on this one. Obviously, these coordinates are junk, and the longer we go chasing them.
What is this, Dot?
Our revised route, Commander.
All right, we came this far.
Upon entering the secret passageway within the already secret Oni facility, we encounter a tram station that is once again reminiscent of those on the USG Ishimura. The 02 on the tram bridge suggests this is not the primary station for the tramway, and that access point may either be inaccessible or intentionally destroyed to prevent the Covenant from detecting it. While the concept of a secret door is cool and all, as we'll see shortly, the amount of infrastructure present behind this secret door would not have been trivial to construct in the first place, so at least during the construction phase of this operation, a more accessible entry point was probably going to be necessary.
Your new AI friend tell you anything else, Dot? Dot.
She's been expecting you.
That's perfect.
Apologies for the unusual security measures, Commander, but the stakes demand it.
Dr. Halsey, casualty reports have you listed as...
Yes, well, as they say, news of my death has been greatly exaggerated. I only wish the same could be said of the rest of Noble Team.
We all do, ma'am.
It may please you to learn that the data module Noble 2 procured from Visegrad Station contained precisely what my scientist promised, a latchkey discovery. It has unlocked, at last, the secrets of this excavation.
Not sure I understand.
Your orders were a pretext to bring you to me and have been overridden. You are here, Team Noble, to ensure the delivery of this vital data to a secure location.
Doctor, our orders are to destroy all sensitive material.
Others will handle the demolition.
I'll need to confirm this new directive with command.
Colonel Holland will be briefed. You belong to Oni now.
As we descend, we make our first encounter with what can only be described as sufficiently advanced technology that will defy our attempts to review it.
Before you is an alien artifact neither human nor Covenant in origin, advanced beyond our comprehension, until now. Thanks to Noble 2, the decrypting of its data is nearly complete.
Whatever we're doing down here, we better do it quick.
Have your data ready, ma'am. We're coming to you.
The decrypting process is still underway.
I don't think you understand. We're out of time. If it isn't portable when we reach you, it's gonna get buried.
Bury any of it, and you bury mankind's best chance for survival. Commander, you've been wondering what your Spartans died for? They died for this. Please, buy me all the time you can.
Despite Forerunner technology being well beyond our comprehension, there is still quite a bit of human infrastructure within this cavernous system that bears inspection. For one, as pointed out by the meme header in the level, given the shape of the ice formation on the ceiling and the amount of light that is penetrating through it, it seems fair to assume that this cavern was dug out by the research team to further access to the Forerunner artifact. This discovery was most likely made after the discovery of the Covenant, and so it was prudently recognized that this technology could be valuable to either side in the war. Thus, the excavation of this cavern was likely undertaken in such a way that it would not be visible from outer space, while simultaneously allowing the team inside to save on lighting costs. Now, it is also interesting to consider that based on some of the icicles we can see in the walls and Dr. Halsey's North Dakota survival gear, that the temperature within this cavern is still likely below freezing. At least on Earth, at a certain point below surface level, the temperature will level off and then eventually increase as you get deeper. However, in proper conditions, it is still possible for ice caves to form underground, regardless of local surface temperature. Now, due to the size of this cave, we're most likely going to be experiencing circulation of the hot air from the ground, generated by the research infrastructure, up to the top of the cave where it will be cooled by the massive ice shelf above it. It's hard to tell conclusively from what we see in game, but if there is also a layer of water above this ice shelf and below the surface layer of ice that we'll see at the end of the level, then this would further serve to provide convective cooling of the hot air within the cavern as the heat from the cave is then drained away into the ocean. The layer of ice and water could also help hide the presence of the Forerunner artifact, whether intentionally or not, by absorbing and attenuating electromagnetic signals from scanning equipment. However, it may still be possible to identify this cavern based on the effects of the interface between solid and gaseous media on the electromagnetic waves used for scanning, if the intent was to search for subterranean caverns. Now, one issue I had with this level, even back when I first played it, was how the Covenant actually managed to find this Forerunner artifact. It's not really stated well in game, but apparently the intent of the story is that they were able to identify the dig site location using information from Oni researchers that we extracted during the first level of this game. I definitely did not pick up on this when I was a kid, and even replaying it now, it wasn't totally clear to me immediately. This also doesn't necessarily explain how the Covenant were able to enter the cave, but given their capability to literally turn planets to glass, drilling through ice is probably not too big of a concern for them.
Noble team, there are 4 defense turrets to assist you in defending the lab. Get them online, and quick. When the turrets take too much damage, they'll shut down to recharge. You'll need to reactivate them when they come back online.
Noble 6, activate the turret to set up a perimeter.
It's also probably fair to assume that Oni suspected that one day the Covenant might discover the location of the research lab, and so preemptively implemented automated defenses should the worst come to pass. The behavior of the turrets is rather video gamey in nature, as they will simply recharge upon taking damage, rather than becoming mechanically disabled, and for this complex of a system, it's probably beyond the point where we can explain this by using self-healing materials. As previously alluded to, the excavation of this massive cavern, as well as the construction of the extensive research facility, would have been a pretty substantial logistical undertaking. And if this cavern is mostly a natural formation, or perhaps if it was dug out by the Forerunners in some way, the construction of the research facilities would still require a significant amount of materials to be delivered and handled within this cavern. In addition to implying a more accessible route to reach this cavern, this would also probably have required a significant amount of personnel, whether or not assisted by fully robotic operators, and so keeping this operation a secret would likely be at least as great a challenge as keeping secret the construction of Sword Base above. The impression I get from the wiki though is that Oni is pretty good at this sort of thing, and there are a variety of ways to prevent information from being leaked. This level also introduces us to the Spartan laser, which if nothing else is worth mentioning in this review due to how cool it is. At its core, this is relatively simply a directed energy laser weapon, utilizing a low-power targeting beam to assist with aiming, and an extremely high-powered beam that produces the blooming effect that we discussed in New Alexandria. In addition to power delivery using a laser beam, when a laser blooms and forms a plasma channel, it is also possible to send an electrical current down this channel, known as an electrolaser, which could in certain circumstances be used to increase the power delivered to a target. This approach may not be as effective against flying vehicles though, since they would not be directly grounded to the same planet as the operator. I also found it interesting that on the wiki, the lore reason for why you can't ever pick up ammo for Spartan lasers is because the charging device for the batteries of the weapon and the weapon itself are never included together as part of the same shipment. Covenant. To be fair, since the device operates purely off of electricity, then it technically doesn't even have ammunition that you would need to reload. But even still, a removable battery would still be a nice feature. Now, unless for some reason this design is actually necessary in order to compact the device into something that is man-portable, with the no doubt endless military budget of the UNSC, it seems more likely that it could perhaps be an intentional design choice to increase the developing contractors' return on their development investment. The war economy is still an economy after all, and military corporations are still corporations. After holding the line against the Covenant to provide Dr. Halsey sufficient time to finish decrypting the Forerunner data, we can finally access her lab and come face to face with the technology tasked with saving humanity. There is perhaps some irony to be noted that in this case this technology happens to be an AI, but unlike modern AIs, this one is actually intelligent. I'm also going to include most of the cutscenes that follow from here, both for the sake of progressing the story so that we don't miss out on any context, and because it's just a great story.
What is this stuff?
Knowledge. A birthright from an ancient civilization. This AI is its custodian, and she has chosen you as her couriers.
Chosen? By an AI?
By this AI, yes. Her measure of you carries as much weight as my own, perhaps more. You are to take her to the UNSC shipbreaking yard in Azad. There, you'll find a Halcyon-class cruiser waiting to get her off-planet.
I understand.
Do you? Mankind is outmatched. When Reach falls, and it will fall, our annihilation is all but certain. Unless we can glean from this artifact a defense against the Covenant. A game-changer. On the level of the conical bullet in the 19th century, or faster-than-light travel in the 23rd.
And what if we can't?
An apt question, if there were somewhere else to place our hope. There is not. Take it, Lieutenant. She has made her choice. Do you have it?
Yes.
Say the words, please.
I have it. Dr. Halsey, Noble 3 will escort you to Castle Base.
I require no escort, Commander.
June, make sure nothing falls into enemy hands.
I'll do what's necessary, sir. Good luck.
You too, Rifleman. I need a heading dot.
At 3 kilometers north, turn right, heading 050.
Which leads to?
The shipbreaking yards in Azad. The only off-planet extraction point left on this continent. Small-scale air attacks have decimated many convoys en route. An armada of Covenant cruisers is hastening to the site as well. UNSC cruiser Pillar of Autumn is awaiting your arrival.
Wouldn't be a noble mission if it were easy.
As a final note before concluding this level, the magnitude of the explosion that we're about to see suggests that the UNSC has deployed nuclear weapons in an attempt to prevent the Forerunner artifacts from falling into Covenant hands. And with that, we can end this level with a subdued bang as we move on to the final level of the campaign.
Noble Leader, seek immediate medical attention. Noble Leader, please respond. Please respond. Sierra 259. You are alarming me.
Not sure how long she's gonna stay together. Skies are jammed up anyway. Gotta get you off her, Lieutenant.
Sir,
you don't want to hear it. Get the package to the Autumn.
Done.
Not yet, it's not. Emil, go with him. It's a ground game now.
It's been an honor, sir.
Likewise. I'll do what I can to draw their fire. 6. That AI chose you. She made the right choice. On my mark. Mark!
In such dramatic fashion, we find ourselves in the final full level of the Reach campaign. By this point, the Covenant has overtaken much of the planet, and the only play now is to leave. Presumably, by now, all but one UNSC ship within the area have left the planet or have been destroyed, leaving only one possible route for escape.
Here's our destination, 6. Pillar of Autumn. Race you to her.
We can take a look at some of the larger details of the Pillar of Autumn once we get closer to it. However, a comprehensive review of the vessel would probably be best served in another review. This level presents us our first opportunity to ride a Mongoose ATV. As we talked about with the Scorpion, one of the more interesting details of this vehicle from the wiki is that it too runs on hydrogen fuel. Unlike the Scorpion, however, which used hydrogen fuel cells to charge batteries, the Mongoose is stated to use a hydrogen internal combustion engine more akin to gasoline or diesel engines that we see today. This approach has been implemented in some modern-day vehicles, although hydrogen fuel cells are generally able to provide higher efficiency than an internal combustion engine. However, internal combustion engines can reach greater efficiency at higher loads, making them more well-suited for certain applications. Perhaps one example of this could be a delivery mission for a high-importance military asset while carrying heavily armored personnel. The Mongoose is also notable for not having weaponry installed by default, and while there are weaponized models that we see in the Halo series, this would perhaps more easily allow the vehicle to be considered dual-use technology, increasing its viability for both military and civilian markets. Or perhaps, at the very least, it would require less effort to convert a military model to a civilian version. Off in the distance, we can see a highly aesthetic arrangement of colors amidst the stormy skies of Reach. No doubt by now the planet's atmosphere has been highly destabilized by continuous plasma bombardment, and the extensive destruction of the planet's infrastructure would have released a variety of chemicals into the atmosphere in very significant amounts. The result is effectively a plasma-induced nuclear winter. This would further serve to achieve the Covenant's goal of rendering a planet uninhabitable as a result of glassing, as even undestroyed portions of the planet would likely still be subject to the cataclysmic effects of the nuclear winter. On our way to the shipbreaking yard, we pass by a number of small buildings. Most of these are located in proximity to what appears to be a security door, presumably leads directly to the shipbreaking yard. It is then perhaps likely that a lot of these buildings are intended for shipping and receiving purposes, as well as security checkpoints to prevent theft or unauthorized transportation of military technology.
Noble, you've got a situation.
Mother! We can get past this, sir.
No, you can't. Not without help.
Commander, you don't have the firepower.
I've got the mask.
Silent copy. Hit him hard, boss.
You're on your own, Noble. Carter out.
Crevice to the east. Let's go.
As the clock winds down on the little that is left of Reach, the Covenant's forces become stronger as they consolidate and converge on the final remaining target. And with the precious time bought by the sacrifice of Noble Leader, we now approach the graveyard of ships.
This is Captain Keyes of the Pillar of Autumn. We are tracking you, Noble, and we've begun our launch sequence. Proceed to dry dock, platform D. I'll be on it myself to receive the package.
I'll be there, sir.
Better be, soldier, because my countdown is no abort.
The Assad shipbreaking yards are used to recover useful resources and valuable technologies from existing UNSC ships once they have reached the end of their service life. Spacefaring and military natures of these vehicles likely involve some significant differences from modern ocean-based shipbreaking. Since these vessels are designed to fly through space, in order to actually get them back to the ground, they would presumably still need to have a functioning engine, or perhaps at the very least an anti-gravity system, in the absence of larger ships capable of towing them down to the surface of the planet. This would then also probably necessitate the continuing operation of the ship's fusion reactor, although conceptually the ship could perhaps be retrofitted with an alternative power source for decommissioning. This is also a condition for modern-day spacecraft, which must be capable of safely deorbiting themselves at the end of their lifespans in order to prevent the generation of additional orbital debris and to prevent the collision of these vehicles with other spacecraft or from impacting something important on Earth. Especially for vessels of this size, the orbital debris potential could be massive, as well as the potential for damage due to impact with a derelict UNSC battleship. In the case that the ship's engines are no longer functional, a space tug could be used to either push the ship into a different orbit or send it on a safe deorbit trajectory. For the ships that do successfully make it to the shipbreaking yards though, this would most likely enable salvaging of the ship's propulsion and power generation systems, which would no doubt be extremely useful to the construction of new ships. Undamaged portions of the hull could also perhaps be refurbished, as could most other spacecraft systems, potentially even including military equipment. This does introduce the potential complication of damage due to military engagements, which could potentially render the ship unable to land due to damage to propulsion systems, although it might still be perfectly capable of operating within space, or damage to the fusion reactor, which, as we've discussed in several reviews by now, do not suffer meltdowns as nuclear fission reactors do. But nevertheless, the cascade of failures resulting from a destroyed power system could potentially render much of the ship either unusable or unsalvageable. With all this in mind then, this would probably then suggest that the most common case for the hulks in the ship graveyard is that these are vessels that have reached the end of their service lifetime and or have been outmoded by newer technology. This may be due to end of life of critical components of the ships that are not trivial to replace, but which doesn't affect the usefulness of other important technology aboard the ship that can be salvaged for reuse. Additionally, due to the military nature of these vessels, it may also be the case that they are no longer fit for service for similar reasons.
Autumn can't wait forever. Let's go, 6!
For components of the ships that cannot be refurbished and reused in new vessels, some of the economic value of the ship may still be able to be recovered by melting down metallic parts and either reusing the metal for construction or selling it off. As alluded to earlier, this might also potentially help reduce the likelihood that military technology might fall into civilian hands. This would also allow damaged portions of the ships to still be salvaged for some value as well. The whole shipbreaking operation also makes me think that an economic study of the UNSC battleships, or any large space vehicles of this scale for that matter, would also be a very interesting research subject if any qualified experts happen to be watching.
Hold here. What's the situation?
We rigged the mass driver up top. If we lose that, the Autumn has no cover fire.
She'll
never make orbit.
Noble to Keys. We're at the pad.
Copy, Noble. My Pelican's ready. Clear an LZ, and I'll meet you there.
Will do, sir. All right, 6. This is it. I'll man the big gun. You just get to the platform and deliver that package.
Here we finally make our closest approach to the Pillar of Autumn. Once again, a ship of this scale would necessarily require an anti-gravity drive in order to fully operate within an atmosphere. However, as we'll see at the end of this level, a controlled liftoff and landing could be achieved with the use of additional thrusters that are attached to the vehicle, which are then discarded once the vehicle has reached sufficient velocity for its primary thrusters to take over, or once it gets close enough to the docking mechanisms to capture it. It seems most likely that the ship is not going to be held up continuously while it's docked at this location, but nevertheless there is still likely to be some sort of ground support equipment preventing the vessel from simply resting directly on the ground beneath it, and also to help ensure a safe and effective liftoff.
That was too damn close.
This is Keys on hot approach to Platform Delta. Ready to take possession of the package, Noble. Good to see you, Spartan. Halsey assured me I could count on you.
Not just me, sir.
They'll be remembered. Cruiser, adjusting heading for the Autumn. Noble 4, I need fire on that cruiser or we're not getting out of here. Do you copy?
You have your window, sir.
Bridge, this is the captain. We have the package. Returning to the Autumn, over.
Copy that.
Who's next? I'm ready! How about you?
Lieutenant, get aboard! We gotta get the hell out of here!
Negative. I have the gun. Good luck, sir.
Good luck to you, Spartan.
The final obstacle to the package's safe transport off of Reach is left down to the final member of Noble Team to handle. The Onager Mass Accelerator Cannon is a 5-stage coil gun that is utilized to fire metallic rounds at extreme velocities. This is accomplished using the magnetic field produced by a coil of wire when a high current flows through it. Arranging these coils in series along a barrel allows them to be triggered sequentially, producing additional boosts to the projectile as it passes through each coil. With a multi-stage coil gun, this means that the firing time of each stage has to be controlled such that they fire in sequence after each other to avoid slowing down the projectile instead of accelerating it out the barrel. Because the operation of a coil gun relies on high currents rather than high voltages, what is usually done is to store energy in capacitor banks and then discharging those capacitor banks into the coils. This allows the energy stored in the capacitors to be built up more slowly, allowing charging to be performed by slower or lower current systems. The usage of capacitors to discharge the energy is essential since the energy must be dissipated through the coils very quickly to produce the greatest current and the greatest resulting magnetic field. This is also probably a good time to remind you that I am a mechanical engineer and not an electrical engineer, so if this is more in your field than mine, please feel free to correct me in the comments. Now if we look at the design of this cannon in game, we see that there are 5 spark gaps over top of the barrel, beneath which are a series of flat plates mounted normal to the barrel along its length. Now as I've described, mechanically at least, coil guns are relatively simple systems. You have a barrel, a projectile, some coils, and some capacitors, and charging circuitry and timing systems, but you get the point. The cannon that we see in game does not obviously possess most of these components. The metallic plates along the gun's length do at least allow for a complete loop to be formed around the projectile's path, but they are of a very small thickness, which even if they were still used to house coils, would significantly reduce the available cross-sectional area for the wires within the coils, which though potentially leading to an increase in the total current density, which would serve to increase the magnetic field produced by the coil, it would also greatly increase the rate of heat dissipation from the coils, which could quickly lead to thermal management problems. Furthermore, the gun does not appear to have much of an actual barrel outside of the autoloader at least, which could introduce the possibility that an offset in the angle of the projectile when it's fired could potentially result in it impacting one of the coils along its way out the gun. If the weapon's magnetic fields are intense enough, this may not be as significant of a concern, but a barrel could also potentially help increase the muzzle velocity of the projectile if it were possible to evacuate the barrel of air to reduce the air resistance upon the projectile while it's accelerating through the gun. While the magnetic fields from the coils would be more than capable of pulling the projectile into them, it could also be possible to fire the projectile using a more conventional chemical system, such as gunpowder, to give it some initial velocity as it enters the magnetic fields of the coils. We also see that the space between the coils, or plates, appears to heat up upon charging, as indicated by the orange glow. This could perhaps be just due to heat dissipation from the coils once the current flows through them, but this shouldn't actually happen until the coil is fired, since there shouldn't be any current flowing through it otherwise. We also see that the autoloader portion of the gun has some built-in thermal management solutions, which is a nice touch, and it is able to achieve some additional cooling by opening up flaps on the spinning armature. The direction of which the flaps open suggests that it has a form of ratcheting behavior, preventing it from getting stuck if the flaps remain open while it's spinning down. However, I suspect that additional enhanced thermal cooling potential could be achieved by having the flaps rotate such that they scoop air inside the cooling device, rather than simply allowing it to escape. As far as why the autoloader is spinning, this could perhaps be used to build up an electrical charge to be used in an initial firing coil, and or could be used to provide a spin to the projectile, since in the absence of a rifled barrel, it might not get it otherwise. This would probably introduce some additional complications into the calculations of the magnetic fields, which is probably well beyond my level and also the level of this review. Even though this weapon doesn't necessarily utilize any sort of chemical, conventional processes for accelerating the projectile, it does still produce a significant muzzle flash and cool sound when firing. This would be due to the extreme velocity that the projectile is impacting the air in front of the gun, as that air necessarily becomes compressed and heated, resulting in a shockwave forming ahead of the projectile and creating a sonic boom. It is also interesting to note that it is probably for the best that this weapon is actually able to achieve escape velocities with the fired projectiles. If this were not the case, then eventually, as with all guns, these projectiles would eventually come back down to the planet, but due to their intense speed, it may be difficult or impossible to predict where they might land, and you really wouldn't want a projectile with such an immense amount of energy randomly crashing into the middle of a city. However, this also introduces another potential non-military use of this technology, which is to launch objects into space without the necessary propulsion systems that we need today. Now, you probably wouldn't want to have people aboard a projectile that has this tremendous amount of acceleration, but this technology could potentially still be very useful for launching cargo into space, potentially even sending it to other planets, which could be incredibly time-consuming given conventional propulsion systems. This could also potentially allow this technology to be used for nuclear waste disposal by just firing it straight into the sun. And of course, if the technology could be scaled down to the point where it produces survivable accelerations, it could also be used for interplanetary travel by humans. For here and now, though, the massive acceleration imparted to even small projectiles would be enough to deliver significant amounts of energy to a target, which is precisely what we need in order to enable the Pillar of Autumn to lift off from Reach.
Good, Spike. All stations, brace for cast-off. Pillar of Autumn. We're away. The package is with us.
With the package away, though Reach may be lost, the day is saved. And now there's only one thing left to do. For the final level of Reach, I only have a few things to say. At least to me, the music that opens this scene is very similar to the music that plays in the opening of one of the best scenes in the first Rocky movie, where he realizes that there's no way that he can beat Apollo Creed. What makes it the best scene, though, is his realization that it doesn't matter if he wins or not, but what really matters is that he's able to go the distance and stick it out till the very end. Across this final battlefield, we can find the bodies of 13 dead Spartans. We don't get any indication of who they are or why they're here, though Noble 6's arrival does result in 2 pairs of 7 Spartans. The best idea I could find online was that this location was a rallying point for any remaining troops left on Reach. Its proximity to the Azad shipyards and the Pillar of Autumn launch site mean that any personnel that were already en route to the Pillar of Autumn would be able to divert to this location after the launch of the Autumn. Oddly, there are no Covenant bodies alongside those of the Spartans, although they could have been removed by surviving Covenant forces, or it could simply be a gameplay optimization. As one of the last points I want to make in this review, I just want to highlight one of the best writing elements throughout this game, since nowadays it seems like we rarely get stories this good. In every case throughout the game, each of the members of Noble Team died as they lived. George went out firing perhaps one of the biggest weapons in the UNSC arsenal, knowing it would cost him his life, but believing his homeland would be saved. Kat, the brains of the operation, was killed by a headshot while trying to figure out the logic behind their orders. June, always on overwatch over the rest of the team, escaped from Reach while keeping watch over one of Oni's greatest assets. Carter, the fearless leader of Noble Team, went down with his ship to save his crew. Emil, always up close and personal on the battlefield, took down a Covenant zealot with him in hand-to-hand bladed combat. And Noble 6, the lone wolf who had found a pack and had it taken away from him, fought the Covenant to the last man. What better way for any of us to go than to meet death in the very manner in which we lived? Finally, we have finished the fight and completed our review of Halo Reach. Aside from its outstanding story and very engaging gameplay, the game presents a very authentic and believable vision of the future, with only rather minor hiccups in explaining how the technology that we see works. Only rarely is this significant enough to detract from the believability of the events of the story. And on those rare occasions that we do encounter, the technology that we see is covered nicely with our 2 miracle exception allowance. In fact, given the presence of alien technology in the series, it could perhaps even be argued that we were overly restrictive on our description of realism, and a more exhaustive review of Covenant technology could perhaps fill in some of the gaps that we saw. Of course, with the immense scope of the Halo universe, there are still plenty more topics that can be discussed in this manner, given enough time and mental bandwidth, of course. At least for today, though, we can say pretty conclusively that in addition to its epic story and superb gameplay, Halo Reach is mostly realistic from a technological standpoint, at least when following the guidelines set in this video. Now, there's also another interesting point of comparison we can make as part of these conclusions between the universes of Halo and Dead Space, which are set within a few decades of each other in the early 26th century, and both of which I now have done reviews on, which you can go check out at your leisure. Obviously, the histories of these two stories are quite different and not necessarily directly comparable, but the two of them together paint an interesting picture showing the contrast between two different visions of how the future might look. Dead Space is characterized by an atmosphere of despair, with worlds on the verge of collapse due to Malthusian catastrophes and resource shortages, all worsened by corporate greed and religious fanaticism. This stands in stark contrast to the future depicted in Halo, in which humanity has been largely successful in their efforts to settle on other planets and expand their thriving civilization to take advantage of the opportunities afforded by these many new worlds. Perhaps an interesting subject for future research could be to identify the points where those two timelines diverged from each other. One potential difference could be the effective and widespread implementation of nuclear fusion power, which to a large extent may have solved many of the problems that the marker promised solutions to. A political scientist could perhaps find some interesting contrasts in the development of Halo's unified Earth government and Dead Space's EarthGov, but this is very much beyond my realm of expertise. There are most likely many other factors that would contribute to this vast difference between the two universes, but the availability of energy and resources does seem to have a significant part to play in dividing the two. And while this may be a rather biased take, given that I am working in the space industry, this also seems to underscore the importance of advancing space travel to the point where humanity can become an interplanetary species, while simultaneously ensuring that the technology is both very effective and widely beneficial as well. But this is all getting into a much bigger picture further into the future with a lot of moving parts, so rather than speculating too much on the future of humanity, I'd rather just focus on building a space station and talking about Halo. On that point, this is also probably a good time to say, thank you very much for watching. As you can probably imagine, these reviews take an immense amount of work, but seeing that so many people enjoyed these videos and get a lot out of them really makes me enjoy the process of making them even more. As I've said throughout this review, I always enjoy seeing people's feedback to these reviews and looking for places where I can clarify things better, or if there's anything I should focus on more in future reviews. So if you have any feedback to share, I'd be more than happy to read it in the comments below this video. Now, to close out this review, I do have one final comment to make regarding Halo Reach. One thing that really stuck out to me during this review is that Halo does a fair job of setting a scene of an apolitical war, something that would be nearly impossible to do with humans on both sides. This isn't to start a political discussion, though. The point is, in this setting, Halo can discard much of the baggage that comes with military settings and instead focus on the soldiers who take part in the war. The Spartans and Marines fighting against the Covenant are not doing so to claim territory or resources, but to ensure the survival of humanity. This then is a key point of the characters in Halo. Their fighting and dying on the front lines allows those at home to continue living in peace. This then is what truly makes these soldiers noble.